advanced training. And yeah, as I said, I have prepared a lot of hands-on stuff for tonight, I have to say. But let's start slowly. The important things first, the training will be recorded. And we will send you an email, yeah, let's say 5 days after the training, so around that. But about me, short informations. My name is Kuemmel. I'm, yeah, I would say senior Java developer, project manager now. I'm involved on several projects. MicroStream cluster development, so I'm mostly in charge of creating things within the cluster and doing stuff within the cluster, architecture and so on. And I'm also involved on some Allianz and Fraport projects, especially with EclipseStore and MicroStream. And of course, I'm also trainer and conference speaker on some different conferences all over the world, I would say. But yeah, I think that's enough about me. So you see my email down there. So if you have any questions after the training, so feel free contacting me via this email. So I will try doing my best to answer everything you want to or you need to know. In some cases, I have to forward this to our developers, or I have to forward you to GitHub discussions maybe. But yeah, mostly I'm able to answer the stuff. Okay, this is the timetable for today. So we started at 5 and the training will go till 9. Somewhere in between, we'll have a short break for around 50 minutes. Yeah, and hopefully this will be successful for you. So some further information about the material. I already mentioned that session will be recorded. You will also get access to all the code examples, repositories, and demo projects of that training. If you have any questions, feel free to ask them at any time. So type it in in the chat. I think we are 21 people there. I think it makes sense to have this within the chat. And from time to time and during some topic changes, I will stop and I will answer the question when the time is right for the specific question. And if I forgot something, just remind me at the end of the training so I could get the answer then. But yeah, ask as much question as you can. So this is why the training is for. Some links I want to share with you. No worries, I will copy this also within the chat. So just a second. That was the wrong one. But let's do it like this. So yeah, let's do it. Do it like this. Do it the easy way. So just copy this. Here we are. Okay, here are all the links to the training. The first 3 links are the links to GitHub, to the main example pages of EclipseStore, and the 2 links that we provide. The second one is the normal EclipseStore documentation. There is many informations in that documentation and covers mostly everything you need to know about EclipseStore. And last but not least, this is my the training examples, the GitHub. It's my own GitHub repo. There you will find all the example projects, also from all the other trainings, like the fundamental training or advanced 2 training. All that stuff is in that repository. Here you will find everything. And we will also do a lot of stuff during the training from this repository. So next and last point is the certificate. You will get a certificate after it. I think it's in the same email like when we share the record with you. So you will get this 5 to 6 days after the training. The important thing is, sorry, that's wrong. Sorry, that was before. For now, it's working like this. You have to register on our cloud platform with a specific email, and it must be the same email address you registered to that training. So if that is the same email, then after the training, so I would say 4 to 5 days after the training, you will find your certificate within the certificate area of the cloud platform. So let me show you this. So just a second. So, okay, so let's try this. Yeah, that works. So that is the cloud platform. Just register there with the same email address you registered for the training. And you will find the certification section here. And yeah, around, as I said, around 4 or 5 days after the training, you will find your certificate here. Just click on the button and then you will get the certificate here. And you can download it, you can print out it, whatever you want. Okay, so let's move on. Let's go, that brings me to the topics. As always, I start with a small warm-up project or exercise. I think it makes sense that I will do the project directly. So I will do it and I will explain it, and you could also do it on your side or keep along with me to program. It's totally up to you. Yeah, I think that makes sense. So it saves us a little time. So okay, then we want to talk about advanced configuration. So the different types of creating and configuring a storage. Then I brought you 2 example projects, one for storing data to the S3 bucket as a storage target, and one for I would say a proper Micronaut integration, how to work with Micronaut. And it's quite similar to Spring. So it looks like, yeah, barely the same, I would say. And that's okay. Then we go to storing advanced. So we talk a little bit about eager and lazy storing. We will talk about transactions and rollback. I think that's an important topic. And that comes along with exception handling. So it fits best together here to talk about a little bit about exception handling and what are the most important things you have to consider when you use EclipseStore. Then a main topic for today, I would say, is lazy loading. So we will do some research stuff, how EclipseStore behaves when we use lazy loading. We will talk about a proper object model, which one fits best to your needs and what is possible structures within your object model. Maybe we talk about lazy collections, but this is only a short point. I brought you an example project with Apache Lucene, for example, to see, okay, how it works with Lucene together and what could be a solution for you having an index, for example. That's all part of the lazy loading stuff. Then we have to talk about LegacyTypeMapping. That I spoke a little bit about LegacyTypeMapping in the fundamental training 2 weeks ago. But now we get into detailed and show, okay, what happens with my class changes and how could I handle that? Yeah, LegacyTypeMapping. Last but not least, we have to talk about backupping stuff. There are 2 different backup scenarios available within EclipseStore. One, we call it a continuous backup and also a full backup. And I also brought a project for writing main storage to hard disk, for example, but creating a backup within an S3 bucket, for example. So different configurations, I would say. So yeah, that's the topics for today. A lot of stuff, I would say, interesting stuff, especially the lazy loading part. And yeah, let's move on, I would say. Yeah, and of course, question answers. So that's quite clear. Okay, let's jump back for a short moment, just asking you if there are any questions so far. So maybe you tried the Eclipse Store out, and there are some questions. I get some smaller emails from you. Not sure if the guy from the email is here, but I answered the smaller questions. Yeah, we will see. I've been learning. Okay. So sorry, what means TDD? I hope it's okay, I understand. Oh, okay. Test-driven design. Yes, of course. Okay. Okay, we will see. So if there are any questions, feel free to answer, and then let's move on. So first of all, I want to summarize that a little bit for those of you who joined today for the first time. You need to know what Eclipse Store is and what do we talk about. So Eclipse Store is just a Java framework. That's the very important point at the beginning. It's not a server or stuff like that. It's just a framework. So you could add it via Maven or Gradle. I don't know if a jar is possible, but maybe yes. So it's totally up to you. It's part of your project, I would say. So it's not a server where you can install it or something like that. It's a framework. And the basic stuff is, or the basic thing is, it's a from scratch invented object graph serialization. That means totally new invented. It's not based on the normal Java serialization. It's our own invented object graph serialization. And the big thing on that serialization is that we are able to serialize to any other system, let's say on the market. So the file system, of course, AWS S3, Kafka, relational databases, DynamoDB, Redis, Azure, and many, many more. At the end, it is just a binary blob on your hard disk, or a little bit more than a binary blob. Some more files and are there, but the basic format is a normal binary format at the end. And now the special thing is that we are able to update that serialized data on your hard disk partially. That means when we thought about the serialization from Java maybe, or JSON, you always have to serialize the whole graph again and again, because you will not be able to update the JSON file at the end partially. And that is a totally different approach. So we are able to update it partially. And I think that's the point where Eclipse Store comes or becomes a little bit of a database at the end. So just to mention that most of the data, or at the beginning, all of the data stays in memory. So because it's an in-memory database, I would say. And most of the data except the lazy parts. So it's possible to set some lazy markers. I would call it, let's call it markers. You will have in your object graph, and that leads to the point that all the data behind those lazy parts stays on the hard disk as long as you call a get method, and then with that get method you will load the data at the end. And there is no data mapping or mapping annotations or stuff like that necessary. You just need your normal Java POJOs, and you could use it with your Java POJOs at the end. So, and it feels like, I forgot this always, it feels like a little bit just working within the RAM. You don't have to care about storing data or stuff like that. Just change your data within the RAM. Of course, when you change something, you have to call a store method on the changed object or on the changed reference holder, I would say, but I will explain this a little bit later. But it's all about working within your RAM. And Eclipse Store takes care about to keep RAM and storage synchronized. So this is what it is, basically. Okay, and to give you a little bit more information or a better understanding how it basically works, I prepared an warm-up project. So we will do this together. And this is the scenario. So this is the exercise for you. So if you want to code along with me, you just take your IDE of your choice, IntelliJ, Eclipse, whatever, and check out the project car exercise. So let me just share the link with you. So make it easier for you to copy paste it. So here we are. So it's the car exercise here. That's the link. And that car exercise consists of two branches. One is the main or master branch, and one branch is named start exercise here, I guess. I think that is the branch is named start exercise here. And I think that's the branch where you should start when you want to code along with me. For all the others, you could check out the project and follow me within the master branch. That's totally up to you. You could focus to answer question, whatever. It's totally up to you. We have enough time to try out a lot of things. Okay, this I already explained. And there are some classes already in place. So you should not have to create some new classes or stuff like that. Just use the classes as they are, but we have to fill it. And this is the setup I talk about. So there is a DB class we have to fill. There is a car controller and a brand controller. And we set the channel count to 2 and the store target to data. That's what we want to do. Okay, so I don't need this anymore. Okay, that's my postman. Ooh, everything is so big. Okay, so I opened the project here, and I'm on the right branch. Start exercise here. That's my branch. Yeah, as you can see here, there is a brand controller, car controller. Some domain classes are already in place, and we could have a short look into these classes. So let's open the company, the car, and the brand. And you see really straightforward Java classes or Java pointers, I would say, with a name in it, and get and set methods, doesn't matter. For those of you who ask, could we use records, for example? Yes, we could also use records within EclipseStore. That will also work. You could use Lombok. It's also possible to use it together with EclipseStore. No problem at all. So yeah, the brand. Then we have a car class. With the car class consists of a model and the brand, which is it's how to say, it's from the data type brand. So we already see this, and we have a company, and the company is a special class, I would say, but I will come to that a little bit later. And there is the DB class. It's empty for now, and that's it. So the whole project itself, it's a Micronaut project. If you want to start that project, you have to enable the annotation processing of Maven. So at just a second, when we have it in Eclipse, you will find this on the preferences, Maven. Then you will find the annotation processing, and you should set it to experimental or to automatically. It should be enabled to run Micronaut application. I think it's the same or nearly the same in IntelliJ. So it's a part of Maven, and you will find it within the configuration. Okay, yeah, you could have the link. Just a second. So we'll share you the link again. Here it is. So no hurry. We have enough time doing that. Okay, so are you ready to start? Okay, let's move on. So the first thing we need, and which is already in place, let me just open the POM XML just to ensure we have all the dependency that we need in place. We usually need these two dependencies. Storage embedded configuration and storage embedded. These are, I would say, the most important dependency we mostly use when we use EclipseStore. The first one, this is the main dependency, and the second one enables you to do some configuration stuff. And yeah, we want to do that, so we need that API to configure stuff. It's already in place. It's not the latest version. The latest version is 1.4.0, I guess. Within the next 1 or 2 weeks, the version 2 will be released of EclipseStore with a lot of features, and also the enterprise version will be part of version 2. But yeah, that's some further stuff. So there is one question: is it a big pain to upgrade from MicroStream 7 to EclipseStore? Correct? No, it's not. So you have to change some smaller things. The API stays. I would say the API stays totally the same. There are no changes. The only thing you have to do, you have to upgrade your persistent type dictionary, because we moved some classes from to another project. So, and the class path names are changing, and you have to do this also within your storage. So not really a big deal, but you have to do this. There is, by the way, one migration guide also available, but yeah, it's not really a big deal upgrading from 7 to EclipseStore. Okay, so let's start with the DB class. And before I get into it, some of you might say, okay, this is static stuff within Micronaut and so on. Normally, this is not a Micronaut training. I knew there is a much better way to implement EclipseStore within Micronaut and so on, but it's just a training for EclipseStore, and I want to keep it as simple as possible. So that's why I doing totally wrong stuff, I would say, for Micronaut. But at the end, I will show you a proper way how to implement this in Micronaut. But that is not part for these projects. So, and based on that, I start with static elements. So I call it public static embedded storage manager, or yeah, this one here, embedded storage manager. And let's call it storage manager. So this is the first and also the most important class and object within our project. It's kind of like the database management system. Whenever you want to access to a store functionality, or to some other functionalities within the storage, you always call the store manager, and it provides you the functionality you will need, or you need. So the store manager is the first important point, and the second one is our root object. So as you already knew, EclipseStore needs one root object on top of the graph, so as an entrance point to all the sub entities below. And in that case, I would use the company itself. It's a business object, I would say, and company is my root object. So let's create an instance of company. So let's say public final static company, and let's call it company, but let's call it root to make it, and let's say new company. Here we are. So we could also use final on that point above here. So it makes sense. Okay, so to initialize both elements, I also use a static block. Yeah, keep it simple. And storage manager equals, And now we start with that point that we want to use the builder pattern. So embedded, storage configuration. And that embedded storage configuration provides me a builder pattern. So let's call builder. And now I'm able to set different stuff. So let's go on with .set channel count. So we will talk about those channels a little bit later. So channels could be 1, 2, 4, 8, always a power of 2. Set channel count and set storage. Come on, set storage directory. Let's call it data. That's what we want to do. Based on that configuration we created now, so we create a foundation. It's always these 3 steps are needed. So you need a configuration. Based on that configuration, we create a foundation. And based on that foundation, we create the storage manager itself. Create embedded storage manager. And this is an important point where we are on line 20. So do not forget to hand over your root object. That could be a big issue when you create your project. If you forgot to pass the root object here, the storage will not work at the end. So you could add some values and that will work fine. But at the end, when you restart the project, you will see nothing happen. So it's important to hand over the root. And after that, we have to call the start. This is also sometimes, or it happens to me that I forgot to start the storage itself, and I'm wondering, okay, why it isn't working. So important, adding the root or passing the root and then call the start method. That's all we have to do to enable the storage. That's it for the DB class. Just to give you an idea of the company itself, this is the root object we talked about. And yeah, at the end, it's a container for all your collections and elements you want to store within your database. It's the object on top of all the other sub entities and so on. You could have multiple collections in it, or also normal primitive values like the name, for example. It's totally up to you filling this root object. People are always asked, could we have multiple root objects, for example? I have to say no, it's not possible. And I think it's not necessary also. So just have one object on top, and that enables you to access all the things below within your storage. Okay, so company, car, brand, we do not need these classes anymore. So exactly, that's one storage for one company. It's just a single instance of a company. We want only to handle one company. So, and yeah, that's all we need. So let's say we are one car selling company and this is our company and it works. Of course, you could have multiple companies. Then you will need a list of companies. Then you have to create an additional object on top. Let's then call it like data root, for example, as a synthetical object on top. And that element or that root object consists of a list of companies, for example. And then you have the things in the same way within your company object as before. So then you have kind of like a, we call it client solution, I would say. Different clients, different companies, whatever you want to create. You separated the company from all the others, I would say. Okay, so DB class is done so far. Let's move on to the controller stuff. So let's start on the brand controller. This is the brand controller here. So you see these are the entry points or the interfaces, the REST interfaces we need to have. So we want to have one to return all the brands that we have stored within, and another endpoint is inserting brands. You see, I changed the get and post methods a little bit. Normally, I will use only get for this to make it callable within the browser. And that's also the reason why I told you to enable a REST client like Postman or stuff like that. Then this will enable you to call these methods at the end. Okay, so get brands. That's an easy task. We need the DB class dot root dot and get brands. That's all we have to do. It's quite easy. As this is what I explained. You have to deal with that stuff. Like it's in your RAM. So your database is the RAM in that moment, and you will return just the brands. That's quite easy. Then the next step, insert a brand. That's a little bit more challenging because when we have a look to the car itself, you see that here we have a brand within the car. And when we have a look to let me just double check the company itself, you see we have also brands within the company itself. So that means we have one list with all brands, but we have also a brand within the car. So this is not always needed. So normally when we have when each car has its own brand, so then it's not a big deal. We could delete that. We do not need this anymore. But the question is always, what happens if we sell the last car with the last existing brand? Let's say there is only one car from BMW maybe, and we sell that car, we will lose the BMW brand in our system. And that's why we need an additional list of brands here, maybe to fill some combo boxes or whatever else you need those brands. And it makes sense. And some of you might say, okay, that doubles the data, right? So so we have a list of brands here, and we have brands in the objects. No, it's not the case. It's just there are just references. So the brand itself is only available once within your RAM. We have multiple references to that brand, and that's why you could have multiple different lists of brands. If there are all references, it doesn't double the RAM. Okay, so brands. So as I explained, we need it, but we have to ensure that when we add a brand, so we have to check if this brand is already available. So, and therefore I created a search for a specific brand, and this is also interesting because this covers a little bit how we query for data. We use the JavaStreams API for querying data. That means let's call a db.root. So this is the entrance point to my graph. That's now we are on the company level. So now we call get brands, root.getBrands. And now we search within the brands. So we say stream.filter, and let's call it brand. Then we say brand.getName.equals, let's use equals ignore case. And then we could reference to our data transfer object. Let's call it .getName. Here we are. So, and we need to have the first one. So I call the find first method, and this statement returns an optional. And as you already know, so we have to check if, let's call it optional in that case. Let's do this. Okay, so we have to check if that optional is filled. So let's use if optional is present. So if there is something in that object, and then we have to negate this. So let's create a new brand. This is really straightforward Java basic stuff, so nothing special. So we create a new brand. We have to say brand.setName, bto.setName. Ah, come on. So get name. So here we are. So let me accelerate this a little bit. No, let's stay here. So now we have created the brand object here. So now we call db.root.getBrands.add. So adding the brand to the list itself. And now we have to store it. And that is a very, very important point. You always have to know what to store. And this is a special thing within EclipseStore. You always have to store the thing which has changed. So that means in our case, we added a brand to an existing collection, right? So that means we changed the collection. And that's the reason why we have to store the collection in that case. So you could explain it in different ways. And normally, I would say you always store the object which has changed. So, or you could say you always have to store the reference holder of that object. It's the same. The collection itself holds the reference to the brand, so you have to store the collection. So that means db.storemanager.store. So you see that, no? The store method is provided by the storage manager. And then we do not have to store the brand itself. So as I explained, we need to store the reference holder. So that means we call db.root.getBrands. And last but not least, we have to return something. Let's say return HTTP response. Let's say okay. And do we need something? Yeah, let's add the brand we created. That's it. Let's do the same on here, down here in line 39. So HTTP response not allowed. So that means whenever the brand is already in place, then we say, okay, it's not allowed. Okay, that's so far to the brand controller. Let me just jump into your questions. Just try to answer them all. Okay, I already answered this. Seems like root object is the same as aggregate in, yeah, maybe, yeah. Okay, this is exactly, I'm struggling with in my own design, how to have a top level collection of objects that are also very deep in the hierarchy. Okay, I see. Yeah, how to have a top level collection. It's possible having a single collection as a root object. That's of course this is possible. So it would look like a little bit like this. So let's create a new array list, for example, or let's say a hash map. We have to do it like this. Map. Let's call it. Let's do string and whatever else. String my map, for example, equals new hash map. Yeah, stuff like this, for example. And you could use my map as a root object. That's totally possible. Should be possible. Okay. Yeah, of course. So I forgot. This will also work. An object is an object. Doesn't matter which type of object it is. You could have a map or a flat object as a root object. It's totally up to you.
Hey, Christian, sorry to interrupt. I was just saying that's what you were doing already with your top level list of brands.
Yeah, of course. But there is that company object in between, and that gives me the possibility to have a single string, for example, also within the field. So that's the reason why. Maybe we have some 1,000 more strings to store within the company, and then you need that flat company object. So, but yeah, you are right. It's the same like that, having this here.
Right. So I'm looking
But
forward to seeing how you're going to keep the list of brands and the list of brands within the car synchronized.
mhm. Oh, okay. I think that's the same way you handle that within Hibernate, right? So you always have to take care about, especially when you use caching stuff within Hibernate, you always have to care about the things, the corresponding things, the bidirectional things. You have to take care about yourself, and I think it's the same. You have to do it on EclipseStore when you change a brand here. You do not have to take care about the brand within the car because it's the reference. If you change the object, it will automatically be changed within the car. So that's a little bit easier, I would say. But when you create a new brand, when you're adding a car, for example, with a new brand, you also have to take care about creating the brand itself within the list of brands. So I think it's in a way the same like with Hibernate. So yeah, you always have to take care about both sides, I would say. Yeah. Okay, so how about the performance to store all brands instead of the new brand? What if the list is huge? A good question. And that's, of course, it's a point. We always have to store the list, but no worries. This will not store always the complete list. This is only the thing you added will be stored at the end, and a small list of an ID, I would say. So each entry of that list has its own index, I would say. And this index has to be written every time. So that's a little bit of a point, I would say. But, and this is also the reason why sometimes it makes sense to creating better structures. I will come to that a little bit later. Especially when we use maybe a hash map or indexes or stuff like that. But yeah, let me come to this a little bit later. But you are right. If collections are growing more and more, each store will decrease a little bit, or the store itself will decrease a little bit. But yeah, we're talking about millions, of course. So it's not really a big deal. Okay, that's what you're doing. Okay, got it. So hopefully I answered so far everything you need to know. Okay, so okay, we created we created the brand controller. That's okay. So any questions to the code, to the store method, how to store it, or to the stream maybe? I'm not sure if every one of you used the Streams API before. For some of you, this might be new. And sometimes it could be a little bit confusing using streams, especially when you use boxed things with streams. But yeah, if any questions so far, feel free to ask.
Hey, Christian, sorry to interrupt again here. So in our insert brand controller here, are we going to update the top level list of brands, or how does that get handled?
I'm not sure if I get it right. So we just add another brand and we stored it by storing it in line 34. Is that what you need to know, or?
No, you're totally right. Okay, never mind. I guess later on we'll see how a brand gets added to a car and then gets added to the brands.
Okay. Okay, I see. Now this is not what happens here. So this is just the list of brands. So, and this is a possibility to add a brand without a car. So
yes, sorry about that.
So that brings me, but that's a good question, to move on to the car controller. So because on that car controller, this exactly happens. So we want to, first of all, we want to list cars, of course, and we already, did this with the brands. So let's move on, db.root.getCars. That's as easy as it can be. So another step is we want to search for some cars, and in that point, I want to search by the model itself. It's the same. So let's start with the stream. I will do this the first stream by hand. The next one will be copied because it's mostly the same. So let's go to the db.root.get cars, and then we say stream.filter, and let's say car car.get model.equals ignore case model. I see. Let me just double check. I think I missed something here. Okay, it's the model and it's the brand. Okay. That everything is great. So nothing wrong happened. So, and then we say dot collect, and let's call it collectors.toList. That's it. That's all we need to do. That should return our list of cars filtered by a specific model within the car. I was a little bit confused because I thought this is the brand. So, and it's just a string. So, but it's filtered by model. So everything is okay. So let me just sort this a little bit. Come on. So to make it more readable. So, okay. The return value is missing so far. So yeah, now we are good to go. Okay. So as I said, we will copy the second one because it's mostly the same. So get cars by a brand. And now you could see, okay, I access the brand itself by the next method call getName. And then I will compare the name to find all the specific cars regarding to a special brand. So that means when we find here a BMW, for example, and BMW is part here of the string brand, then everything is okay. We got back the list. To clear the cars, that's also interesting. So how to delete cars or how to delete things within EclipseStore. Yeah, it's really straightforward. So we have to go to our collection, db.root.getCars. And then on that, we clear the collection. That's it. So we force Java to clear the collection. By the way, the clear method here is a Java-based clear method, or it's a method of all collections. So the standardized way to clear stuff or to clear everything within the collection. And after that, when the collection itself is empty, we call the normal store method. So we call db storage manager dot store db.root.getCars. That's it. And with that call, all the cars are gone at the end. Not entirely from the storage, because we need the garbage collection at the end. So that means that the data will stay within the RAM till the garbage collection runs to delete all these cars, because if these cars are still part of another entity, for example, the object stays in the RAM. That should be quite clear. So that means if you have somewhere a second collection with cars, these cars will stay in the storage. So, but this is normal Java stuff, I would say. And then we return an HTTP response. I will copy paste this to accelerate that a little bit. HTTP response, okay, cars cleared successfully. That's it. This is also, by the way, how to clear things, how to delete things. Just delete the object and then just store the reference holder of the deleted object. Okay, last but not least, we have our insert. And let me just copy paste the whole part to accelerate that a little bit. And I will also copy paste you this to the chat for all of you who want to code along with me. It's easier for you to copy paste this also. Okay, so what we have to do is we have to check for the brand, of course. We have to check if the handover brand is already part of our data structure. So this has happened here in line 54 and 55. So we have to find the right brand. So if the brand is present, we use that brand directly. This is how we ensure that we use the same reference in the created car. Then we create the car itself. We set the brand. We set the model, which is just a string. And at the end, we add the car to the list of cars. And I think that's what I think, Nathan, you was it who asked this, how to add this to a car. And this is where the car and brand comes together. And this makes sense. I'm pretty sure there are thousands of things I not considered in that example, but this is just a small example just to give you an idea how EclipseStore works. Maybe there is a lot more business logic necessary at this point, but yeah, I don't care about that. So it's just an easy example. Okay, and after that, we have to store the reference holder itself. And in our case, it's the car collection. So that means we call db.root get cars, and that returns the cars collection. And this collection has to be stored at the end. Okay. So now we are good to go. Let's try it out. So if everything works like expected, so I have to do oh, come on, I have to do a Maven update first. So just to be sure everything is up and running. Okay, looks good. So to start an application like this, it's quite easy. Just move to the application Java class, the application class here. Right-click, run as Java application, and then you should see this method or this message here in the console. The application is started on localhost 8080, and this is where the Postman comes into play. Just a second, I have to find the right collection. MicroStream training, car exercise. Here we are. So I prepared some examples here. So you see that is the car exercise. Yes, there is a Maven command. Just a second. It's yeah, a short moment. So this, that. I used the right thing. Yeah, here it is. It's just this. You could use this command to start it within your Maven. Just micronaut run. And this will also. Oh, unfortunately, I'm not able to share you this Postman collection. But I think that should be quite easy to create those requests by yourself. So let's start at the insert brand method. It's a post one. Just create a new request. You could right-click on your collection and say add request, and then use the post method itself. And as I already said, it's available on localhost 8080/brands/insert. You could find this when we have a look to the controller class. Again, let's start on the brand controller. You see the brand controller class has this controller annotation in line 14 with /brands, and that's the path we have to follow. And then we could call /brands/insert, and that's exactly what we need here. So localhost 8080/brands/insert. And within the body, it's a raw type of JSON. And then you need this body here. So let me just share this with you. That's the body. It's a JSON type body, raw, and that's all you need. So let's create that fort. So let's send it. Hopefully we get the 200. Unfortunately not. So what I think the port is the wrong one. Let me just double check. Okay. So, okay, I see. Oh, there is something. I changed. I changed this for the example. So, okay. So now we solved it. So let's make maybe an update. Let's just check if the. Okay. So let's start it again. Now it should work. So 8080, just to ensure the port is the same. So let's went back to the postman and try it again. Method not allowed. So did we miss something? JSON Fort. Okay, right. Did I miss something? Brand controller. It's a post insert. Works on my machine. Yeah, you're lucky. So that is a trick. So let me just close this, and then I want to move to team, switch to master, discard everything. So now I'm pretty sure that that will also work on my machine. So so maybe an update. Oh, that's what I so perfect. So you know, live coding is always a mess. So application run as Java application. Now you see there is a different, it's a different port. So that's okay. 8070 is the port. It says so. Okay, give it a try. So send. Huh. Come on. Did I miss something? Hopefully following your example already inserted. Maybe that could be. So let me do a refresh. But okay, that was the reason. Okay, so I see. Maybe this is yeah, that could be a good point. So because there was a storage already available within my project, so that could be the reason. So let's start again. So yeah, because it was not allowed, right? So it was exactly the HTTP response we used. So insert, okay, 8070 send. Yeah, that was the trick. So the Ford was already in the storage. So now let's create the BMW. It's the second one. So great. So we have all the brands in place. Let's say all the brands we need. So let's create a car. So therefore we use the insert car method. It's also a post method. We use the localhost 8080 cars/insert. Yeah, we talk about the storage folder a little bit later. So cars and insert. And let me share the body with you to make it easier for you to follow up. So we created a model M5 with the brand, of course, named BMW. It's the same here. It's a raw type from JSON, and we need to change this from 80 to 70. So let's send this. That worked. So let's create an M3 and M4. So let's just create some of them. That's okay. So if everything is created, so we could use the last call. It's an all cars endpoint. It's a get endpoint, localhost 8070, and then it's cars. And then when we call it, you should get all the cars at the end. Okay, this is what we need to do within the Postman. Not really a big deal. let's jump back to the IDE. So applications is still working. So now you should see there is a data folder down here, which occurs on startup the application. And it's, yeah, to be honest, it's not on startup the application, but it happens at the first time we call the database, the storage manager, I would say. So let's shut down the application and start it again. And you will see, okay, nothing happened. Just Micronaut starts up and that's it. And now at the first time we press on give me the cars, you see that the storage manager starts up, the embedded storage manager initialized, and you see that you get the same data as before. So it's stored the data successfully. So when we call the data, and it's stored within that data folder here. And now we could jump into that data folder to give you an idea how it looks like on your hard disk. Show in System Explorer. Here we are, just a second. Okay, here we are. This is the data folder here. And this is how the storage looks like at the end. So it consists of, in our case, it consists of 2 channel files. We're talking about those channels a little bit later, and 1 persistent type dictionary. And that dictionary is it's kind of like a dictionary of all the types, all the different types of the storage consists. No, so let me move that here. So we only need the persistence type dictionary. Okay, here we are. So this is how the type dictionary looks like. You see that all the flat Java types, and each type has its own type ID, I would call it. And this is the way how we identify the binary object at the end on the hard disk. So each binary element has its own type ID and its own object ID. So each entry consists of a type and object ID. And this is also the point, especially some of you ask how to migrate from one to another. And one reason is there are some types in here that are tied to MicroStream, to the MicroStream version. And this has to be changed at the end. But that's all you need to do. And you see, you will also find the objects itself that is stored. One is the list, of course, and also this is the car. And somewhere else there should be a brand also. It's here. So it's the brand here, and that is the car. And whenever you create a new object, it will be registered in that persistent type dictionary. And yeah, that's important to have that dictionary. So when you lose the dictionary, then you will be in big trouble. So you should never use the type dictionary. But I think it's the same on any other database. So when you delete some files behind the scenes or within the database, you will be in trouble. So okay. The channel files itself contains the data. So that data is split up to channel 0 and channel 1. And the channel folders contains the data, especially the .dat file here. It contains the data. And there is another transaction file, which is only part of EclipseStore itself, of the EclipseStore internally transactions. So it's not made for you to see what's going on within the storage. It's just an internal transaction file. Okay. Okay, so let's have a look to your questions, if there are some. The all cars get 4 more seconds in Postman, of course. So just all cars. So maybe no, there are no params. It's just there's no body, nothing else, no params, just a straight get request. You could also call it within the browser, so nothing special in it. Okay, so Let's wait for some more questions on your side. If anything clear to you, I think that was the first part, the warm-up part, just to keep all of you on track. What happens next?
Hey, Christian.
Yeah.
So you switched to the master branch, but did you ever find out what we had wrong initially? I still couldn't get it to work.
No, let's say I don't care.
Okay.
Yeah, maybe it's just a small error or something, or small bug somewhere. But yeah, it's always, as I said, it's always live coding and doing things wrong, and yeah, nothing special, I would say.
Okay, never mind. I just got it to work. I had to add the @body annotation.
Okay.
In
Within the
insert
controller,
brands.
right? So within the card here?
Yeah.
Maybe, yeah, maybe you are right. Maybe there is somewhere something. Let's jump back. Let's give it a try. So maybe it's an error. Team switch to start exercise here. Okay.
I mean, you don't need to spend time on it. Like you said,
Okay.
it doesn't matter. I just,
Yeah.
I got it working. Thank you.
That's by the way the reason why I'm doing this within different branches, because that happens. Sometimes everything works like a charm, but sometimes nothing works, and then it's always best to switch to a branch which you know, okay, this branch is working. Yeah, it's always with live coding, it's always a problem. Okay. I guess it's good to exclude EclipseStore data folder from antivirus scan to make file. Yeah, of course it is. Definitely. Yeah. That makes totally sense. To exclude the data folder. Yeah. Okay. Let's move on. So this was the warm-up. Let's move on to a more detailed topic, the different ways to configure. And I prepared a small presentation for that. Advanced storing. Let me just check advanced configuration. Here we are. That's the right one. So we need, yeah, just a small presentation about configuration. So as an example, or just as an example, there are 1,000 different ways to configure stuff. You could renaming the storage directory, you could renaming channel directories, data file prefixes and suffixes, and so on. There are many different possibilities to configure. When we jump into the documentation itself, let me just show you that. Here there is one part when you open the storage part, and then you will find the configuration here. And then on properties, you see all the different properties that you're able to adjust and to configure. On some of that we will talk about a little bit later. Unfortunately, not the housekeeping itself, because housekeeping is part of the Advanced 2 training, but we will talk about the channel count and some read-only stuff and so on. And you could define some maximum file size that could be interesting in some special configurations, clean up head files and so on. There are many different possibilities how to configure it. Yeah, I think that's a good point to show or to read within our documentation, just to give you an idea what is possible. That's what we already that we have already seen. So let's talk about the storage channels. Basically, the channels are the I/O threads that EclipseStore use to store things to your hard disk. So that means with the channels, we separate the lock mechanisms of the hard disk to store data in a multi-threaded way. So as I already explained, it's always important to have this within the power of 2. So that means you could have one channel, 2, 4, 8, 16, and so on. And as I explained, it allows the storage to write down data in a multi-threaded manner to the hard disk. And it's mostly useful for writing heavy binary data, for example, when your storage has the main focus of writing a lot of binary images or documents or whatever else. It makes sense to have more than one channel, or handling heavy write workloads, for example. It makes sense because it accelerates the write itself. But on the other hand, multiple channels are segmenting the data at the end. So, and this reduces the read performance at the end. So you have to find your own sweet spot between 1 and 8. This is, in my experience, I would say choose something between 1 and 8 channels. And this is working totally fine. At the end, you will be able to change this. So that means I already explained this, a power of 2. And when you're changing stuff the easy way, just changing that within the code from 2 to 4 or 4 to 8, this will not work. So you have to migrate the storage at the end. And an example code for this looks like this. So that means when we have those channels here, so the basic configuration was 2. Oh, sorry, I clicked on the code. So, but yeah, let's jump directly into the code, because I created a project for you just to see that channel migration. Here we are. So let's go directly into the code. So and this is an example. Let's start this. So this will run also. So let's first things first. Let me just share you this. That's the link of the project. Okay, so that's the link. So there is no storage available for now. So let's start it. Application. So let's run as Java application. Okay, and there must be one method which is called setup data. So let's call this within my browser. Let's say localhost 8080, and then books/setup data, I guess. So this, you see the storage is initialized, and I get the message within my browser, book successfully created. So, and is there another one? Starts with, okay, it doesn't matter. So when we have a look to the storage itself, let's make a refresh here. You see the storage here, and now you see there are 2 channels, channel 0, channel 1. So that's what we expected. Okay, so now I created a main method here. And within that main method, I will do the migration from 1 to 4, from 2 channels to 4. So that means I created a source configuration. And the source configuration needs that 2 informations: how many channels and where is the storage based, I would say, and it's in the storage folder here. And this is the target configuration: set channel count to 4. And yeah, just a few system out print lines. And now we need to use the storage converter, and it converts from source to target. I call start, and the conversion is finished. So let's start this. Okay, so it's finished. It changed from 2 to 4. And when we do a refresh now, we should see it's changed from 2 to 4 channels. Okay, so that means, let me just jump into your questions. So there are some I've seen. So are the channels duplicates? No, there aren't. So it's, let's call it, need to find the right word for it. It's not a replication. It's an, what is the second one? Come on. It's late in the evening. So
like a partition.
Yeah, but yeah, yeah, there is a specific word. So maybe I remember 5 minutes then. But yeah, it's not a replication. It creates yeah, the data is segmented into different channels. So how do we know if when we need more channels? I think it's a thing on the performance. So I would say give it a try to find out what fits best for you. Maybe you could measure the performance, or you could see the response times. It's not always that easy to find the right way, but I would recommend start with something in between 2 or 4 channels. That is, you will be totally okay with that. The more channels you create, you will see the more your read performance will decrease, because you have to collect the data from all the different channels and put them together. And yeah, I think something between 2 and 4 is totally enough. I promise you. Sharding. Yeah, thank you. That's exactly the word I'm looking for. So sharding. So it's kind of like a shard. Okay, thank you. Okay, and that's all. That is the channel stuff. So it's, as I said, it's mostly created for writing heavyweight data or heavy data like binary objects and so on. If this is the primary focus of your storage, storing documents, which is, by the way, totally okay for storing stuff like this with Eclipse Store. It is working really great. So then you should consider having multiple channels than only one. Yes, high performance is file system. This is, by the way, what we always recommend. People always ask, what makes more sense, having the primary storage on AWS S3, for example, or having the storage on my hard disk? The primary thing is, I already explained this, the data is in your RAM anyway, except the lazy parts. So that means the reading performance is not relevant if it's on S3 bucket or if it's on the file system, because the data is in the RAM anyway. But when it comes to the point where you want to load lazy stuff, then you have to go to the database or to the hard disk or to the S3 bucket, and then it differs a lot. So because when you talk with S3 bucket, you have all the data transfer stuff in between, all the communication stuff in between, then S3 bucket is a lot, I would say a lot slower than the file system. And that's the reason why we most of the time recommend using a persistent volume, for example, especially when you use Docker containers or Kubernetes. Then we recommend using persistent volumes. Then that means you have your primary file storage on a persistent volume. Then you will have a second persistent volume for the continuous backup. We will talk about this a little bit later. And you could create full backups to your AWS. So you separated the different stuff to different storages to improve your disaster recovery and whatever else you need at the end. But yeah, I would recommend using file storage as the primary storage target. Okay, so I think that answers all your questions. Okay. Is just a general question. Who you run queries against the data. Okay. So hopefully I'm able to show you that there is a small example here as an example. So there is a second endpoint here within the book controller. If that inside the channel migration thing, we are using the Streams API, and the Streams API, or mostly we would recommend the Streams API because it's the best way to query all your collections and the whole object graph, right? So that's and it's the Streams API, and it works. I would say it works the same like any other query or SQL on your relational database. It's not the same way how it works, but it's, in my opinion, it's in the same way powerful than SQL, I would say. Do you have a special support for lazy collections for Streams API? No, not really, because if you want to stream through a collection, you have to load it. That's clear. So that means when you want to stream through a huge collection, let's call it huge, let's say millions, you have to load it. And that brings me to another part, which will be handled a little bit later when we talk about lazy and how to use lazy loading in a proper way. You have to take care about this, yes, for sure. So, but it's quite easy. But if there is a lazy element within your stream, let's say, for example, let's say these books are lazy books, for example, then you will see later you just have to call a get method here in between. Then it looks like this. So that means that brings you to the lazy level. So get books, you will get the lazy level, and with the get, in that moment when you call the get method, the data will be loaded from your hard disk. That's how it works. But of course, to stream through your collections, you have to load it, and that's why you need different strategies in some parts. So you recommend to start with a local storage that later move to cloud storage like S3? No, that's I think that's so that's just an example. So I always would recommend having the data on your hard disk, persistent volume, whatever else. When you use Kubernetes, keep it on your hard disk, because that's the closest part to your application. For later things, especially when you want to back up the data, or you want to have kind of like a disaster recovery and you have to store the data somewhere else, you could create a backup on S3 bucket, for example. And that's what I mean. But the data stays, the primary storage stays on your hard disk. So that's totally okay. But storing things for backups, you should use an S3 bucket. But if you want, you could start on your S3 bucket directly at the beginning. It's totally up to you. Some of our customers are using their normal databases. Maybe they have an Oracle database already in place, and they said, okay, we're using that Oracle database as a store target because all the backup things are running in the background within. So, and then it's the same way working like with your hard disk. You just have to create your own connections, and EclipseStore serialize the data directly to your Oracle database, and it creates a binary blob within your database. And that's it. And they use their Oracle databases because they are already there, and the backup is running in the background, and this is why they used it. To be honest, it's not my favorite thing doing that, because yeah, but you can do whatever you want. Maybe also for later. Okay, there's a way to inspect the data without implementing a server with endpoints. Yeah, that's. I think that's a little bit of a problem. Not call it a problem. So there is no way or no easy way to inspect the data. So of course, when we use a micronaut project, you will always be able to create an endpoint to see what happened within the storage itself. Then it's an easy game. When you create an application without REST endpoints, yeah, you have to find a solution for this. But we provide it's not part of the advanced training, but when you jump into our documentation, you will find where is it? There is one point which is called REST interface, and there is a client UI. And that client UI enables you to see what's going on within the storage. So that means this enables a small REST interface within the framework. It's only for development purposes. So there is no, you have to remove it when you go to production. But this client UI enables you to see what happened within the storage. But it's also a different way how it looks. So because it's an object graph, right? It's not a table as you are used to have it within your relational database. It's a little bit different, but it shows you the data of your storage itself. Yeah, it's the client UI. You find this within the documentation. It's normally part of the fundamentals training. Okay. Is there support for loading by collection interface? Oh, that's, oh, I have to understand this. Let me skip this for the moment. Just jump to the next one. What about reporting? Yeah, I would always recommend using REST for reporting stuff. This is because most of the reporting frameworks and servers and toolings and whatever, they are also able to handle REST endpoints. And this is what I would do. So create REST endpoints to share the data with all the reporting systems, and they could use REST also instead of using SQL directly. So this is, yeah, I think that's the explanation. What about reporting? There is no embedded functionality regarding reporting. It's just the storing engine itself. Okay, I tried to understand Alexander's stuff. Is there support for loading by collection interface? Not actually implemented class like data root contains. I'm not sure if I get it right. So, Alexander, could you please give me a small explanation about, or a simple example, what you mean? Is distributed open source, multiple nodes, so coordinating some data store, multiple nodes? No, distributed is not open source for now. So the framework itself, it's open source, but all the, let's say, distributed stuff, so data replication and so on, is part of our enterprise model, and it's not open source so far. So it's, for now, it's closed source. You will never know what happened in the future, but yeah, the framework itself, it's open source. Okay, I would say let's move on. Time is running out a little bit, so I want to share with you some further configuration stuff. So here we are. So we talked about channels. So, and as I said, there are many more options. Housekeeping, for example, this is part of the Advanced 2 training. Just give you a short idea, housekeeping is how the garbage collection is working in the background. Backup configuration we talk about a little bit later, and there is surprise, there is a read-only manager, and that was also I read it today when I prepared the training. There is a read-only manager. It's also part of the documentation, and that enables you to accessing a central storage unit read-only. But there are some restrictions. Maybe it's helpful to you, but normally it is one virtual machine per storage. So there is it's not possible to accessing one central storage from multiple machines. That's not possible. But with that read-only manager, it's possible to access. But there are some restrictions. It's not part of the training so far. Maybe I will create an example for one of the next upcoming trainings, but not for now. So, okay, so let's move on. I think that's all from the configuration part. I want to share with you the different types of configuration. So I created another project. Just a second. Here we are. Just to share the repository with you. Okay. Okay, MicroStream configuration. Let's have a look to this project. It's here within my IDE. So let's jump into. So we have our normal structure that we are used to have. So let's open the DB class. And let me just double check if we are on the right branch. No, we have to switch to configurations. Done. Discard changes. Okay. So that's okay for us. So let's jump into the DB class. Here we are. And now you see, this is also maybe, that's for sure interesting for you to know. You could have multiple storage manager within one project. That's totally up to you, creating multiple ones if you need this. That could be helpful, for example, migrating stuff from one storage to another. Yeah, for whatever. And for each storage manager, I used different ways to initialize them. So one is the very basic one. This is one of the getting started. That's the easiest instantiation of a storage manager. Just call embedded storage.start, hand over the root itself, and you have to hand over also the path of the storage itself, and that's it. That's the short way to initialize it. Then there is an XML way, and of course also a YAML part. So class path, this is Micronaut stuff, I would say, but at the end, you load it from an XML file. Let me just show you that file. Where is it? Let's just delete this. So we do not need this. So where is it? The resources, I guess. Yes, here it is. So the XML looks like this. So you will be able to use a property file like this to set up your project. That's possible. The builder pattern, we already used this. I would say I like this the most. So this is what I most of the time use, except when I'm using Micronaut, then it's a different approach. And then there is the most complicated way to initialize the storage itself, but also the most powerful thing, especially when you want to have different storage types. For example, a combination of persistent volume and AWS S3 bucket and maybe some other stuff, then you have to do it like this. That this is just creating an embedded storage foundation from scratch and set the configuration. I would say at the end, it's the same like the builder pattern, but it's a little bit more boxed and more powerful at the end, because you have to set different configurations on different framework levels, I would say. Some adjustments could only be done on the foundation, and some adjustments could be done on the configuration. And therefore, it's the most powerful way to initialize, but it's also the most complicated way. I think there are some more YAML file and so on, but just to give you an idea that this is possible, let's start this just to show you that this is working. So, okay, no, that was the wrong one. I need the application here. Okay, so run as Java application. Okay, so sorry, first have to make an update. Okay, that looks like it should be. So you see the initialization of the different storages. And when we now refresh it, you will see the different storages here. This is the builder pattern storage with 4 channels with a backup in it. So we will talk about this a little bit later. So builder pattern, the data, I'm not sure. I think it was what was it? So what was it called? Data. That was root, builder storage, backup directory. I guess it was the XML one. Yeah. Data, then we have the foundation storage. This is the storage, the most complicated way. So with the backup directory in it, it doesn't make really sense having the backup in the same directory than the normal storage is, but it's just an example. So just for you to give you an idea that this is working. So you see, you could have multiple storages within one project and the different ways of initialization. Choose the one which fits best for you. That's it, how it should be. So, and last but not least, I brought you two projects I want to share with you. One is a Micronaut project, like it should be, I would say. So I created this directly today for you to give you an idea how it looks like within Micronaut. It's the newest Micronaut version, 4.6.2. And that is totally different. So that means a lot of packages are within that project. Let me just share this with you to give you an idea how it works. So there is no DB class anymore. So there is no storage initializer within that project. So there is only one application.property file necessary. So you see that there is, these are the configuration stuff. So that means I have to define which class is my root class. And I also have to define where is the storage path. And I could do all my configuration stuff within that property file. And that's it. And based on that, Micronaut does initialize the MicroStream or the EclipseStore storage by itself. So that means I need one root object, which is the root object here. So I have a class which is called books. That's my root object. Some annotations, but these are annotations from Micronaut. Then a repository, that means this is the data access. We will talk about this later. So data access. And some data transfer objects here. Some Lucene stuff is ongoing here, but yeah, we will go into details after the break when we talk about Lazy, because this is also a Lazy example and how to use Lazy in combination with Lucene. This is really great and working good. And this is the controller. And as you can see here, especially when we talk about not the data transfer, the DAO class. So all the important stuff will be injected on startup. So via constructor injection. So that means you will get the storage manager and the root provider here, and you will get this via this constructor, but this is handled within Micronaut internally. We do not need that DB class anymore. We do not need any static class anymore. So this is everything is handled by Micronaut. So let me share this with you just to. This is always great having those projects, see what's going on and how does it works. So that's the repository of the project itself. A lot of questions are within. How to describe the difference of foundation and configuration? Oh, that's a hard question, I would say. There are different layers of within the framework itself. To be honest, I'm not able to tell you the exact differences between a foundation and configuration. I knew that these are different layers, and you could do adjustments on the different layers. But what is the reason for that? So I have to ask my developers for that. It's too deep knowledge, I would say. But it's open source. If you are interested in, just have a short look to. I think it's a thing about encapsulating all the different layers from each other, and that's also the reason why we have those foundations and configurations. And it's all built on interfaces and so on. It's quite technical stuff, I would say. Class loader provider, not in that advanced 1 training, but class loader stuff is part of the advanced 2 training. It's not really deep knowledge, I would say. We knew that for some reasons you need different class loaders for Spring, for example, and also for what is the name of that application server? It's Wildfly. Is it Wildfly? I guess. Wildfly needs its own class loader, for example. There is an example within documentation how to use different class loaders with EclipseStore. We knew that this is a topic, but it's part of Advanced 2. But I would recommend having a short look to the documentation. There is one example how to define the class loader for EclipseStore and for the different other stuff. Maybe that helps a little bit. Okay. Hopefully that answers the question a little bit. Okay, great project. We will dive into that project deeper later. And there is another one I want to share. It's one example. It's an S3 example project, which is also part. Let me also share this. It's all about showing you different types of configurations and how to handle this. This is also a Micronaut project, and there is a DB class here just to show you how to handle accessing an S3 bucket, for example. This is we started like normal. We have a storage manager in here. We have a root object in here, and then we started with embedded storage start. We hand over the root, and then everything within EclipseStore is a file system, and there is an S3 file system which can be loaded here. There is a blob store file system calling new, and then you need your S3 connector. So we will use the normal AWS API S3 connector for creating a file system class. Then you have to set some properties, the region and the bucket, for example. Of course, you need to have your credentials and so on. Having that, and then you can start, then it works like a normal file system. It's all based on that file system. Everything could be a file system. Even your relational database will be a file system at the end. And it's all that stuff is prepared, and all that stuff is also covered within the documentation. So just have a look to the documentation and to my project, and that's it. So okay. So one question is, does have to be careful regarding garbage collection? No, not really. Keep it as it is. So there are two. So I have to. It's more in detail explained in Advanced 2. There are two garbage collectors working. One is the normal Java garbage collection. You have to take care about this garbage collector, but to be honest, you don't have to, so it's just running in the background. You will not notice it. And there is a second garbage collection within EclipseStore. We call it housekeeping, and that housekeeping has two reasons. The first one is EclipseStore is an appending storage. That means whenever you change something, for example, you change the name of a customer, for example, the whole object will be attached to the end of the storage. So that means you will have two objects in different states at the end. And there is a housekeeping process. And let's say you call that changes 10 times. You will have 10 times attached the object at the end of the storage. And the housekeeping takes care about of deleting the older ones. So this is one part of the housekeeping. And another part of the housekeeping is handling all the stuff ongoing on your hard disk. So when we talk about what was it? The housekeeping interval, you will see that when you're doing heavy writing stuff on EclipseStore, you will see that you will have multiple files within your storage folder, because each file has a maximum size of 8 megabytes. And if these 8 megabytes are full, another one is created, another one. And you need a housekeeping process that put everything or shrink everything together and clean up all the files at the end. And that's the housekeeping process. Normally, you will not have to deal with it, but especially when you create a system with heavy writes, for example, then maybe it makes sense to increase the CPU and the CPU to allow the housekeeping using more CPU doing housekeeping stuff to clean up all these things on heavy write. So, but normally you don't have to care about this. Okay, So I think for now, we are good to go. Let me just have a look to the presentation just to know. Okay, so we missed this part before the break, but that's not a problem. I will put this at the end of the training. So there are so many questions. So yeah, let's see. Let's go into the break now for 10 or 15 minutes. So I would say let's meet back at 7:05, right? 5 minutes past 7, Central European summertime. And then I directly start with lazy loading. And I think that's quite interesting for you, lazy load, because I will enable what is the name of that tool? Just a second. Where do I have it? Visual VM. So, and with the Visual VM, we will see what's going on the RAM. And I think that answers some of your questions we have now. Seeing what's going on, how the storage is working, and how many objects could we store in what, and how much amount of RAM and so on. Let's do this after the break. Okay? Coffee, tea, let's move on. So there was one last question relating the graph objects on heap. To be clear, all the objects are on heap except the lazy ones. So that's quite easy. So everything you have within your storage is on startup of the storage manager will be loaded from your hard disk except the lazy parts. That's what it is. Yes, we are working on some more advanced collection types for EclipseStore. We call it GigaMap. It's a combination. Let's say it's a combination of a special index and a chunk-wise storing data. There are multiple different chunks, and all the chunks are dynamically loading and releasing and so on. It's it's a component which is part of the enterprise framework, and it's coming next. But there are also some other situations which can handled totally easy. And yeah, let's talk about this. So this is exactly the next topic, is lazy loading. And let me just open the presentation for you. Okay, let's move on. Lazy loading. Here we are. Okay, so lazy loading. We have to clarify, why do we need to store and load data in a lazy way? What data should be stored and loaded lazily? How to use the lazy references, and of course some best practices. So we did a lot of projects with EclipseStore and MicroStream in the past. Also for big companies like the Allianz Insurance Company, and also the German airport Fraport. Some of their baggage handling system is based on EclipseStore. Also all the handhelds, the Android devices which handles all the luggage and baggage and so on, is there is MicroStream and EclipseStore working in the background. So we are used to use or handling, let's call it big data in a way. But yeah, let's talk about this a little bit later. How to release this, that's also an important point. So when we lazily load data from the hard disk, we should be able to release data at the end if it's no longer needed. And yeah, it's also part of the documentation. But I think the best practices are the most important stuff. So why lazy references are important? As I already explained, it's an in-memory database. And this is, by the way, also the reason why it is that fast and performant. So I think that's quite obvious. Best performance data is in the RAM. So in some cases, it's impossible to hold the data inside a RAM, especially when binary data comes into play. That means when we are talking about documents or images and binary files in general, so we need to use lazy loading at the end. And sometimes it's just unnecessary to hold all the data inside a RAM, especially when we talk about archive or historical data. So we do not need these data all the time in the RAM. And there is an important point I want to mention. In the past, we are used to putting all the data in one data source. So that means we have an Oracle database, for example, and we put all the data inside that Oracle database, no matter if that data is data which is needed all the time, or it's archive data or whatever. We put everything in one data source, which works all the time the same. And it is always quite difficult to increase the performance for a specific data part, I would say. But this is not the way doing this in the future. So you always need to find the right type of storage for the right type of data, I would say. So if there are, when we talk with our customers and they said, okay, we have, let's say 80 terabytes of data, for example, then we ask, okay, what type of data is it? Is it binary data, or is it data you need all the time in focus, all the time in memory, because you need a high-speed access to all the 80 terabytes of data? And most of the time they said, no, it's data from the last 20 years and we have it in our storage, and that we pay money for that because it blocks the whole database, for example. And that is also, you always have to find the right type of storage for the right type of data. And it's the same in-memory data, so data which is handled within EclipseStore. And I would say not all the data is made for having it within EclipseStore. And that's the same. It's unnecessary to hold all the data inside the RAM all the time. Okay, so that's what I already explained. So that means when we have 100 million objects in our file, we will have 100 million objects at the end on EclipseStore Startup. So this is how it works, basically. Except we are using lazy references. So that means on the left side, we have our object model, and we set some lazy elements on 1, on 4 here, or 4 here on this side. We have 100 million objects still on the hard disk, but on startup, our data should look like this. So that means only the references are loaded here. So that means we need the possibility to go to the object and call the get method. And when we call get, the number 1 will be loaded. That means when 1 will be loaded, then we will get 6 and 7 at a time, because this is not a lazy reference of 1, for example, but 4 stays on the hard disk. So that means we have to call 2 get at the end. So we have to call get at 1 and get on 4 when we want to search or stream through the data at the end. So this is how it works. So the question is when to use lazy loading. So I would say, in my experience, always on binary data. I would say there is no reasons for having blobs, documents, and images within the RAM all the time. And I would say it's not possible at all. So, and to be more, having that in more detail, I would say try to store your blobs, your documents somewhere else, but not in the database. So store it to an S3 bucket, binary blob storage. It's much more cheaper than any database on the market. And it creates huge amounts of storage, and it's quite expensive having this in a database. And it makes even more sense to have it on a blob storage, binary storage, whatever else. Maybe with a direct access. So there is another advantage of those. Maybe an S3 bucket, you will be able to access that S3 bucket directly. So that means when you access a specific image or document or whatever, the stream does not go through your application server, for example. It goes directly from S3 bucket to your client application. That makes totally more sense because it's less traffic on your application server, for example. And there are many more advantages having this not in the database. So you should always use lazy loading on huge collections. So what means huge collections. I would say huge collection, let's say archive data or logs or stuff like that. Always things that are not less frequented. So and we also have to find a way to store this. Let's say we have archive data, millions of data. We are not able to store this within within one collection, for example. Let's say a list is not a good thing to store archive data, for example. But let's talk about this later. So that means huge collection, less frequent data should be loading lazily. Sometimes on collection with huge amount of sub-entities. So that means you should use, let's say we have customers and customers comes with orders, for example, and it makes sense having those customers in one list, but the orders within the customer could be loaded lazily, for example. This is what it means. And of course, whenever you want, you always have to think about your data itself. So I want to give you an example. When, let's say we decided to have our orders, we have our orders lazily. So when our application server loads the orders, then some of the orders will be loaded. We could stream through and so on. So the point is, the more concurrent user we have on the application server, the more data will be in the RAM anyway. So that means sometimes it doesn't make sense to have data in a lazy way, because the more concurrent user we have, the more data stays in the RAM anyway, so, or is loaded anyway. There is one big advantage of EclipseStore. All the persons and all the users and are working on the same object graph. So that means the object graph itself works like a cache at the end. And that's one big benefit of that system. But yeah, sometimes it doesn't make sense to have this the lazy way, because users will load the data anyway to stream through, search for something and so on. So it's totally up to you to make the decision what makes sense, having it lazy or not. So I think that's the point, that not always an easy decision. Okay, an example for binary data. Both situations could happen. So one is we just have one image, then you could do it like this, lazy byte for an image. And this is, by the way it works. So lazy works like a wrapper around, this is a wrapper around an object type. Or you could use it within a hash map. And this is one thing which is important using EclipseStore. A hash map, for example, is mostly not used in combination with Hibernate, but it's such a great collection type, and it makes totally sense using much more hash maps in the future in combination with EclipseStore than with Hibernate. So because they give you so much more possibilities handling your data, a really great solution. So yeah, this could be one solution to having a string kind like an index, I would say, so that enables you to search through that string, and maybe that string could be the name of the document and or whatever else. You are able to search for something, and at the end you call the get on the findings, I would say. And then after that you call image.get, and you will get the blob out of the lazy wrapper. Always a recommendation using hash maps instead of lists or sets. So this is what I already explained. Huge collections. That's also one point. So this is a way, this is what could most of the time could work. This could work. So I would say there's a normal list. So it's lazy wrapped, a list with books inside the lazy element. So that's okay, right? So the problem is, whenever you want to stream through the list of books where you want to search for a specific title or name or whatever, or an author, you always have to load the whole list of books. That means that this list will stay within your memory anyway. So because let's say we have 100 concurrent users, one of that users will always access that list of books. So it doesn't make sense to have this the lazy way. But for some reasons or for some situations, this could make sense having things like this. So smaller collections, I don't know. low, medium-sized collections, but you always have to consider this. In my opinion, makes a little bit more sense. String lazy list of books. It's a structure which is used on our projects a lot. So we use that string as kind of like an identifier or an index. One specific situation could be having the first 3 letters of the ISBN, for example, or the first 4 letters or numbers, whatever, within that string. And that enables you to creating an index through the ISBN, which is a great identifier in case of books. And then you have a lot of small lists of books within on the value side. And then that enables you to search for a specific ISBN, for example, and you will get back a smaller list of books, and then you can do further searching on title or whatever else. There are much more extended things on that, but the basic way storing things like that is a great way doing this. It's the same on string and lazy books. That means you have the ISBN as an identifier on the string side, and then you have one single lazy book. Maybe if that book is a heavyweight entity with a lot of strings in it or whatever, then this could also make sense at the end. I would say this is best practice for huge collection. I will give you an idea later on how to search within and so on. And index could be ABC, whatever. It could also be that we have a second lazy list of, we have one hash map having that ISBN thing I explained before. And there is, let's have another hash map with authors and lazy list of books. As I explained a little bit earlier, that does not doubles the data, right? So it's just, there are just references on that book. That means you will be able to create your own special indexing on that books, for example. So maybe that could help. How to unload the data? That is one possibility. So let's jump into that code. So that means we have a lazy byte, a lazy image. With the get, we will get the byte at the end. And with the lazy image clear, we could say, okay, clear that lazy image, that lazy element, and the garbage collector will do the rest at the end. But the important thing is this is a point where garbage collector has to be, has to run first to free the RAM at the end. So this is one possibility to do it the manual way. That's possible. But there is a second possibility, which is default configured for you. So that means there is a lazy reference checker in the background, and the default behavior is a duration of 30 minutes. That means if an object stays untouched for 30 minutes, it will be cleared automatically. That's the one point. Or if you reach a memory quota of 75%, then all or some of the older lazy elements will be cleared automatically. This has happened in the background. So you could adjust this. This is totally up to you to set up a better lazy strategy for your type of data. Yeah, but these are the two strategies clearing those lazy references. Okay, so one of the questions, so to avoid blobs in EclipseStore, pull them from another location. Do you have an example of this? Not really an example, but so just to give you an idea. So yeah, we created projects working like this. So we have we storing binary data directly to AWS S3, and you will get an identifier from AWS. So and we store a specific index, like a description of the part which is in the description of the image and so on. And then we use a hash map storing the description or a specific business ID, whatever. And on the other, on the value side, we see that AWS identifier. And with that AWS identifier, we call that image at the end. But there are many different possibilities. It's totally up to you. And I think that's also a great opportunity using EclipseStore. You could build whatever you want because it's pure Java. Do whatever you want to build. So now you have the possibility to create business logic which fits best to your application needs instead of building stuff that fits best to Hibernate and some relational databases or whatever. I think that's the point on that. Okay, that's all from the theoretical side. Let's jump in an example project to show you some parts. There is one example project which is called LegacyDemo. So let me share this with you. So you could also do your research on that. That's totally up to you. So let me find the... what a shame. So just a second, I have to find the project first. Yeah, here we are. Okay, so this is the project. It's called LegacyDemo. That project consists of many different branches, and I want to start with just to give you an idea how it works. So let's start on the first one. A new sorry, team switch to. Let's start at the master branch. So let's jump into it. Nothing really special in it. There is one class which is called mockup utils. This is only part of creating data. Just for an example, there is one domain object. It's a person object, first name, last name, mail, gender, IP, and there are two string values here at the end, and there must be on the resources. Yeah, there is a mockup folder which contains a person JSON file, and I would say that these are quite big elements. So just you see that the values here, a lot of strings here inside, and that JSON file contains 1000 elements here, and these elements are loaded on startup and stored to the storage itself. So let me just check if there is a storage already in place. Yes, there is. So let's delete it, data. Okay. Otherwise, there is nothing special. There is a create endpoint. We will use that. And there is an init. It loads the data. And I forgot to start the Visual VM tool. Just a second. It's always difficult. After changing the screen resolution, all the stuff is gone from the desktop, so I need to find it again. Here it is. Okay. So I have to apologize for the screen changing stuff, but yeah, I think it's necessary to show you all that things. Okay, master branch. Let's start it and see. Oh, sorry, that's not. Okay, master branch. So that's the wrong one. Here we are. Okay, run as Java application. Just a second. I don't want to store it. Did I change something somewhere? Maybe. Okay, now we are good to go. Okay. Okay, up and running. So I'm able to start this within the browser. So I call the localhost. You couldn't see this, but now I'm typing the books.create method. You will see it will be initialized. And on the other side, let's move to this is the application itself, just to monitor the behavior. and the threads. So this is the memory part. So application is already up and running with less data. And now I call the create method. And maybe that's interesting for you. The create method creates, it creates 200,000 elements. So it iterates 200 times of that file, and each iteration creates 1,000 persons. So that when we call the create method, it creates 200,000 objects at a time. So let's move on. Oh, is it a different? One moment. Maybe it's a different. No, it's not. Did I miss something? Ah, okay, it's persons create. Sorry. Okay, so here we are. Okay, so it's up and running. So now you see the creation of 200,000 elements. Okay, now creation is done. So we get the message, person successfully created. Here is the, and I'm sure we are able to access them. So persons, we should get a list of persons, but of course, the browser is a little bit in trouble to render all that 200,000 elements. But that's okay. So when we have a look to the storage itself, it's around 1.3 gigabytes of RAM usage. When we have a look to the storage, that could also be interesting. Let's make a refresh here. We should see the data here. Let's go into it. Show in System Explorer. Let's check how big the data is. You see we have around 1.5 gigabytes of RAM on disk space running now. And we see within the RAM, it's a little bit lower. So I would say 1.3 gigabytes of RAM used in heap. So 200,000. And yeah, and that is, I will create it again. So let's create another 200,000 and you will see it increases more and more. This is quite obvious. So when we put data in it, but I think the interesting part is to see how is the balance in between disk space, disk size, and memory size at the end, and how fast it is to store 200,000 or 400,000 elements. It's quite a fast process to store data in it. Okay, so let's stop this and start this again. So we no longer need this. And oh, come on, it's always difficult. So now, okay, let's start that application again. I also start Visual 4M again on CPU memory. So the storage manager isn't start for now. So it's just running the Micronaut project. There is one controller class which is called init. You remember that? So that initialize only the storage manager. Just to give you an idea on loading the data when we initialized the data itself. So where we are here, instead of create, we call now the init. Say the database is initialized, and you see that this is exactly what I explained at the beginning. So the data will be loaded on startup of the application, and here it is. So this is now it's finished. He loaded all the data. It took us around a few seconds, let's say 8 or 7 seconds to load these 400,000 elements from the RAM. Just to give you an idea about sizes and how long does it take to have that. Okay, so this is the basic behavior of EclipseStore. And if this is okay for you, then take it as it is. Use most of your data in memory. You always have to consider this is sometimes that is a some people underestimate the usage of RAM of their application servers, because you always have to consider that people say to me, okay, our application server is running on, let's say, 60 gigabytes of RAM. Then say, okay, that's okay, but you forgot to measure the RAM estimations of your database itself. Have you ever stored millions of data on a PostgreSQL, and do you know how much RAM do you need on the Postgre side? And when you use EclipseStore, you always have to summarize both elements together, because your application server itself becomes your database at this time, and you only need the RAM on one machine. And that gives you much more, much more possibilities to increase the RAM on your application server side. And think about the things what I'm told you, the more concurrent user you have, the more data stays in RAM anyway. So sometimes you will be totally fine having your stuff directly in memory, and that's okay. And it works quite fast to get the data back. Okay, but what happens if we need a lazy stuff? So let me delete the data here. And let's jump into the next branch. Is it possible to support on-the-fly compression for heavy EG collections? No, not yet. Not yet. Because there is an idea compressing data and so on, but it will always be a problem by searching through that data. So maybe the point is, do you want to compress the data within the RAM or compress the data on the hard disk? I mean, on the hard disk, we don't care. We have infinite amount of hard disk space, but maybe in the RAM, I guess. So it could make sense, but searching through that compressed data will be quite difficult, I would say. Maybe it's possible. I don't know how Apache Spark works, but I'm pretty sure you will be able to use Spark in combination maybe with EclipseStore. Maybe that works. I've never used Apache Spark before, so it's quite hard for me to answer that. But that gives me an idea to look after that Spark. So it's interesting to having that. Okay. Okay, let's move on. Change it to lazy. Here we are. So let's team switch to change to lazy. That's it. So here we are. So now you see I changed the root object a little bit. So it's data root. And now you see I have that quite really straightforward lazy lists, a list of persons. And that's okay. We just want to see how the lazy stuff works, basically. So data is empty. Yes, let's start it right away. Okay, I would call that person create on the browser on my second screen. Data is initialized as expected. So I could share this with you. Okay, it's done. Let's call it a second time. So when we have a short look to the app itself to monitor it, we see the same result at the end. It's the same amount of data created, nothing special so far. So it's quite the same amount of data at the beginning. So now we stop that process and we start it again. And now we call that image, you remember, that init method. And now we see the differences between lazy and eager loading. So just so here, monitoring CPU classes thread. So now you see when we now call the init, nothing happened I would say, a little bit more, because we need those lazy references and some of the, yeah, how to say, it's kind of like Hibernate with that smaller references. I'm not sure how the name is now. I couldn't remember, but we need the lazy element references, and this is the reason why we have that amount of data. But yeah, this is the way how the lazy elements are working. Okay, just to shorten that a little bit, there are many different ways to use lazy loading, and I told you that hash map stuff and so on. And I like to directly jump to that Micronaut example I created today with a very detailed or a really great solution using Apache Lucene in combination with EclipseStore. So first of all, it's an example of having books with authors and publishers. Nothing really complicated. There is one root object. Let's jump into this. I mentioned that before. There is one class, it's called books, and this class contains the books itself. The reason for creating a specific books element, I don't know, to be honest, but this is the structure how the books are stored. It's a map with string, and that string contains the it's an index based on the ISBN, and it's the first three letters of the ISBN as an index, and each entry of the index creates a lazy list of books. Okay, so that's it. And now you might ask, okay, how to find the books, how to search within the books, to find a specific title, a specific author, and so on. And that's the reason why I created an Apache Lucene index. So that means I created that Lucene utils class. And that utils class helps me a little bit by creating a specific writer, create a document, create an index, create a searcher, so that it's kind of like the query and so on, search by title methods, an index updater. Also, it's just an helper utils class. So you will need this class to create a Lucene index. And when we now jump into the lazy books controller, so we see the create method here. That means this is the create post method. So I hand over a new book. So I create an insert statement for each book. And that book data transfer object will be hand over to my data access object. And there is one write object. So you might need to understand this, but this I added this for concurrency purposes. So to creating kind of like a write lock handling concurrency stuff. This is, by the way, part of Advanced 2 training. And at the end, there is a root provider. So this is part of Micronaut. This is the root which is injected to the DAO class. And then you see I call a compute if absent. That means maybe there is a key already available based on that three leading letters of the ISBN, and if not, there will be a new one is created. You see that here, and is returned. And after that, I added the book to that new created list, and it will be stored within the hash map. This is pure Java stuff. It's not based on EclipseStore or anything. And in another step, I have to add this added book to the index. And in that example, I just created a mechanism that every 10,000 books, it creates a new index entry. You could do it this way also, creating or updating the index on every insert, but this will decrease your write performance enormous, because Lucene is not the biggest champion in creating or updating the index. It takes a lot of time creating an index, and this will decrease. You could try this out when you call this. It will take much more longer to add a book at the end, around I guess 69 milliseconds to create a book. And with that solution here, especially for heavyweight writing, let's say, I created that solution to writing an index every 10,000 books. Okay, so this is how it works, and let's try it out. So let me just double check if there is a storage already there. Okay, let's delete that storage. We start from scratch. That is working great. So so I will explain this, why I created that example a little later. So okay, so let's start it. Let's give it a try. So application, here we are. So let's start it, run as Java application. And on top of that, I used another tool, which is called JMeter. Maybe some of you might already know JMeter. It's a tool for, oh, holy moly, what happened now? So sorry for, okay, here we are. So it's a tool for, yeah, let's say doing performance test, load tests for some applications. So that means I created, this is, by the way, the insert REST endpoint, and I'm sending books within 10 threads, and it creates those books from a list of 1,000 books which are behind within that file, books collection CSV, and so on. There's a lot of different stuff. So, but let's click on, let's run that example, and then we will see, hopefully, that I set it up correctly. So I start to run it. Okay, it initialized the storage, and for now we see that we have something is working different. Now it increases a bit. So now in average we have 300 or around 370 inserts per second. So that means we are around in average, I would say 19 to 20 milliseconds creating one book. But this is, you see that it decreases and increases, it increases a little bit. So, but in average, it stays on 375, creating that Lucene index and creating those books here. Now we have 24,000 and so on. Let's create 30,000, then we stop it. So Lucene part was a little much for me. Yes, of course. It's, yeah, I would say it's not part of that training. It's just creating or give you the possibility to search through strings and so on, especially when you need a full text search, for example, through a read example of a book or the title of a book or whatever else. You could use Lucene as an indexing engine. It creates kind of like an index, and you could search a full text search through that index, and you will get the ISBN back from Lucene. It's not that complicated than it looks like. It's just a small class, and you have to understand a little bit how it works, but that's okay. So let's stop it. Now we have 46,000 books in it. Everything looks okay. And now let's use the Postman and just double check what's going on within the storage itself. So I have to close things a little bit to don't save. I had to clean up my desktop a little bit, so just a second to make it more transparent for you. Find by title, find by ISBN, count indices. So that's the first thing which is interesting. Count indices, that counts the amount of keys within my hash map. So let's call it, and so that's interesting. It's exactly 642 key entries within our hash map. That means we have 642 lazy lists on the value side, right? So this is what it is. Now let's try to find a book by a specific title, and let's call it. Let's use the end, for example. Maybe there are some books with end within the title. So let's search for it. Oh, okay. Moment, there is something wrong. Ah, okay, I see. That's the wrong. Find by title. This is the right one. So let's search for end. Okay, and here the books are. So now the first call needs 148 milliseconds. That's what it takes on the first one. When we call it a second time, you see, let's say we have 46,000 books in it, 55 milliseconds for searching for the books within the Lucene index, and then after that getting the data out of the storage. So we could change this. Let's say strand, for example. Let's search. Maybe there are some books with stand, for example. Stand there. Yes, see that. This is working really great. So I shared this project with you. Just do some more research how I implemented it. I'm pretty sure there is an implementation of that which works much better than mine, but it's just a small example for you to see what's possible, I would say. Especially for full text search, it's always difficult having a full text search within the streams. There are some basic features, of course, already available, but when you would have specific search algorithms, for example, then it makes sense using stuff like Apache Lucene and so on, working within your application. Okay, so let's restart the application. This is also interesting to see because all the stuff is lazy, right? So when we now start it again, we should see that the memory consumption should be quite low, right? So because everything should be loaded lazily. Okay, application is up and running. So let's call the end one. And then we see the memory consumption. At the beginning, it takes a little bit longer because the Eclipse Store has to start up. But on the second call, we are quite faster. And this is the result at the end. You see that? This is the memory consumption, what we have for calling the end here. Now let's choose the deliver. For example, you see, there are no changes at all, I would say. It has to load the lazy lists at the end, the values here. And yeah, this is working really great. So why I created an example like this? On the one hand, just to give you an idea how this could work within your applications, how you could deal with big data, for example, even if it's lazy loaded, and even if you want to search through, that could be one idea to give you an idea how this could work, basically. But on the other hand, I created it as a performance demonstration compared to the new upcoming GigaMap. And this is that is the reason why I have those performance demonstrations here and the GigaMap example also, because we are working on testing that GigaMap for the new release, I would say. And this is why I created. But I think it's also interesting for you to see how this could work. Even it's an in-memory technology. It's possible having data in the lazy way. And on the other hand, you will be able to search through. And I think that's a big advantage of Eclipse Store. And I think it's great having data like this. That becomes your own database within your application itself. But this is only one example of possibilities. I just want to mention some other things. We talked about sharding, for example. So it could be a great idea, or we have this way in some of our projects, that we provide customers from one microservices, companies from another microservice, orders from a different one. So that means our company, our whole database consists of maybe 10 smaller microservices that makes the database and also the applications itself, or the database itself, much more scalable at the end. And each data provider provides just companies for some of the consumers and so on. And another big advantage is if the customer consumer or the customer provider is not available, on the other hand, the company provider is still there, and your application could run further. So without a smaller, if something goes down, or so that are always big advantages. Sharding data with EclipseStore, not having everything in one big application, that gives you so many possibility to for your architecture for you in the future. Okay, a lot of talks so far. Any questions from your side? Hopefully that topics are not that boring for you, but does GigaMap replace Lucene index? Yes, it will. So with the GigaMap, you would not need Lucene anymore. There is part of the Lucene working in the background of the GigaMap. So, but you will create indexes based on Lucene. Yes, but it's all boxed. It's now in a alpha, I would say, alpha beta state, and it will be released soon. So we are working on it because it's really a great collection. So, and this will increase or give you much more possibilities using EclipseStore in an automatic way. So you could create your own indexes based on the elements you insert to the GigaMap. And that will be really great. So I'm really looking forward to having that component in production. So, okay, so far, lazy loading. Any questions regarding lazy loading? It's a huge topic. I would say the main topic of the training, of the advanced training, but an important one, because it influences your object graph also. So how to create a proper object model that fits best to your application needs, I would say. Okay, if there are no further questions, I start with the next topic. Migrations. What exactly migrations? Migrations from data change?
Yeah, exactly. Altering the data scheme of your objects.
Yeah. Okay, let's do so. Yeah, that's one topic, which is the next one. Let me just clean up my desktop a little bit too. It's a project which is called LegacyTypeMapping. Where is it? Here is it. So let's open it and let me share this with you, because that's also interesting. So okay, here's the link. So LegacyTypeMapping. We call it type mapping because I would say it's divided into two parts. The first part of handling changes is an automatic way. That means whenever you change something, that will be handled automatically. By the way, let me just check if there is I think there is there is a presentation for that. And it makes sense to start with a small theoretical overview of LegacyTypeMapping. So what if I have to change my data definition? And in our case, what happened if I have to change the classes? yeah, just a topic, not that important. Let's jump directly in. So the point to understand how EclipseStore handles data type, I showed you this already in the persistent type dictionary. That means each object type consists of a specific type ID, and at the end, an object ID which identifies the object itself. But the type ID is for the moment the more interesting thing. That means whenever you create a customer like this, a definition of a customer is created within the type dictionary, and it gets the type ID 66 in that case. A little bit with that one before, but yeah, it doesn't matter, 66, let's say. And there is a definition of that class in it, ID, last name, first name, male, and gender, and it's also, it covers the name, it covers the class path, it covers the sorting order of the fields within the class. And yeah, in the storage, it looks like this. We have red ones and blue ones, and it's binary parts and so on. And as I said, each information within the binary storage consists of an object ID and a type ID. Okay, this is what I've explained. So now when we change something, something happened like this. So when we change something, let's say a customer, and we change the, let's say we deleted the address, right? So we removed the address from an object. Then the persistent type dictionary creates a new one, a new type, which has the type ID 67 in that case. And that's it. Nothing more happens so far. So when we start the storage, everything seems to be the same till we first touching the first customer. Let's say we loading a customer, and on load, I would say, the customer will be transformed to the new version, or the new version of that customer. That means all the customer objects that are untouched within the storage stays on the old version. So at the beginning, when we tried to invent a system for data change and so on, we thought about, okay, on startup, we could change all the data within the storage. But this was horrible because it took hours to start a storage and transform all the data and so on. And that leads us to a system that we call type mapping, and it's kind of like a versioning. That means as long as the data type within the storage stays untouched, it stays on a specific version and nobody cares. So, but at the moment we touch an object, it will be transferred to the new version. So, and this is exactly what happens. So that means at the end, you will have a mix of old ones, some in the middle versions, and at the end. But you don't care because you don't have to deal with that. You will be able to force the database to update all the data. That's possible, and it's totally on you. You could do this if you want. That's it. Yeah. So this is the basic stuff, how it basically works. So now I mentioned that there are two different ways. There is an automatic transfer of the data, and there is a manual way. And let's talk about the automatic stuff first. So you see that there are two contact classes here, and there is a basic a heuristic working in the background that detects the changes which are made on the class, and yeah, the heuristic guesses what happened at the end. So based on different values, based on the name, based on the position within the class, based on the data type, and so on. So, and for example, let's see this. This is the old one, the old contact, and the new one. And we do several changes here. So we change from name to first name. We change, so we changed name from whatever element. We leave first name as it is. We removed age as far as I can see. Oh no, we moved it down. Okay, sorry. So and so on. So, but the heuristic is able to exactly fits best for the migration. So that means he already knew that first name is moved to one line up, last name is renamed, email address is renamed, support node is renamed, and all this is guessed by specific values within the Java class. And this is working, to be honest, really great. Sometimes I try to find a situation where I could say, okay, you will. It's impossible that you will see or you will guess what happened at the end, and it's quite hard to find a case which is not working so properly. Okay, at the end you will see stuff like this. When you start the storage itself, it will print you out the guesses, what could happen. And if you're okay with that, you could say, okay, that's exactly what I've done. And this is also the reason why we always recommend not doing huge amount of changes. It makes totally more sense doing smaller changes after another to upgrade a storage to some different changes. And because it ensures that some parts could go wrong, right? So this is, that's it. And then you can press yes, and then it's the storage is okay with it. No, you don't have to deal with it anymore. Okay, I think that's it for now. Yeah, best practices. I want to mention this. During the development, when we are able to delete the storage all the time, and I would not use that heuristic that much, because we are able to set up the whole storage again and again. It's also best practice having great technologies for mock-upping data. Try to find a good way to create test data or mock-up data, and then just delete the database and start it again, and it will be recreated, and that's it. Do not use the heuristic that much. It doesn't make sense, really. That's also what I've already said. Changes multiple attributes in one class should be done step by step. That makes totally sense, instead of doing them all at once. Of course, you should create a backup before you updating the storage. I think that's, yeah, really best practice. But there are some special things that couldn't be handled in an automatic way. For example, changing the data type. And changing a data type from, let's say, string to integer or integer to string or whatever, this needs special migration logic for sure. And I think that there are no big differences to handling that changes compared to a relational database with Hibernate and so on. You will also need a special migration business logic to transfer a data type from string to integer or stuff like that. So compared to EclipseStore, there are not that big differences at the end. It works a little bit different, but the amount of effort you need to migrate the data is, I would say, barely the same. So or nearly the same. Sorry. Okay. But how to handle this? So such special migration stuff is just create a new attribute or a new field. Then you start the application, and it could be on startup that the data is transferred to the new attribute. Then you could transfer the old field to the new one, or stuff like this. And this is how it works. And then you shut down the application, then you will be able to remove the old attribute at the end. This is one possibility. But it could also be possible using the get and set methods for transferring the data at the end. But this leads you having such a code all the time within your project, maybe not the best practice way. I think it depends a lot on your project you're working on, and what strategy will fit best to your project handling, I would say. It's a little bit up to you, Henning, but a lot of talking. Let's jump in. Let's see how it works. So legacy type mapping, let me check the branch that we are on. Okay, let's start at the master branch. Storage should be deleted. Okay. And it's always the same. Let's start the application. So, and there's nothing special so far in that project. So let's start it, run as Java application. So up and running. So let me just jump in the controller. Authors, oh no, oh yeah, there's only an authors controller, but that's okay. So I call the local host on my browser on the second screen, localhost 8080 authors / create, right? So this is, okay, author successfully created. Let me share this with you. Create, is there another one which shows it? Get author, great. So, okay. Okay, there is one author in it, right? So it's totally enough for us to see what's going on. So we have our author consists of 3 strings: mail, first name, last name. Okay, so I stop the project and now I switch the branch. So let's see that mail, first name, last name. Okay, so let's switch the branch. Team, switch to changes stage 1. So now you see we did some changes now. So we renamed the author. First name stays the same, and we changed the name of the last name, right? So this is what we have done. So let's start the application again. So now you should see EclipseStore, let me string authors. Yeah, that's it. So now you see this is what the heuristic finds out. It says, okay, there is a field within the author which is named mail. This is the old one. And it is changed to, let me just move this. So, and it's changed to mail author. So this is what he guesses from the changes. So first name is the same, it stays the same, first name, and last name is changed to name. And this is how it works. Write yes to accept the mapping. Yes, let's do this. And now the application starts up, and you see this is the result at the end that we get from the JSON. And you see it's changed now. It's called mail author, first name, and name instead of last name of the changes before. So you see most of the time that heuristic works for you really great, especially when we talk about an application which is still in production or already in production. And changes in production are not that heavyweight, I would say. Maybe yes, of course, when we're talking about big changes and so on, but there are a lot of stuff is working really great with just an automatic transfer of the data. How you do this, or if you want to do this on production, on directly startup, or if you transfer some of our projects, we do it in a way that we download the storage, we update the storage, we're doing some tests on it, and then we upload the storage again, and then this storage is working in production again. So it's always different. It depends a little bit on the changes we made, and but you always have to create a backup, of course, and then this heuristic or this legacy type mapping works really great. Okay, so any questions so far? So let me just take a little bit coffee. So, and I just want
to... So, sorry,
oh,
just a question. I will ask it by because it's long to write. So when you are saying that the order is changed now, the handling, it means in the Java code, the mail author goes to the line 10 if you open the author class. So
you say that he knows when you just, okay, this is also a change that he knows to handle. Okay. So it basically bind it to the line on which the field is written.
Yeah. Well, let's try it. So let's try if it works. So okay, it starts up. So where is my browser? Oh, I'm an expert. I closed it. So just a second. Localhost. Authors / authors. That's it. So now you see it changed. So first name is now running on top. Last name male. He did the change now because there are some changes are not fully registered. So you see the last name and male, but it's but this will work. And now you see the male is here
on the bottom.
On the
okay, thank you.
The bottom. Yeah. And so there are many things that are handled automatically, but if you really want to keep control on everything, and if you do not trust that heuristic, it could be possible, and maybe it makes totally sense doing that the manual way, then we implemented another or a second step, I would say. You could do this also the manual way. That means you will find everything within that legacy type mapping topic here. And there is an automatic mapping. This is what we talked about now all the time. But when you scroll further down, you see there is an explicit mapping also. That means you could provide a class or a file that looks like this one. So it's a refactoring CSV file. And within that file, you will be able to set all the changes that you have done. And then EclipseStore will exactly map these changes from old to new ones as you defined it. So I would say this is the next step, especially if there is a special thing that could be handled in an automatic way. Let's say one example, which is a quite weird example, but let's say there is a name and we change it, and let's say there is name 2, name 3, name 4, name 5, name 6, and so on. So you are adding further name fields, and you want to migrate the name to name 7, for example. So I don't know why to doing that, but it could be the case. Then you could use that explicit mapping to say write it directly there. And an interesting point is when we now have a look to the storage itself, we will see what's going on in the persistent type dictionary. So I think that's again an interesting point. Now you will see that different type of versions of your author. See that? Now we have version 69, 70, and 71 with all the changes which are part of the storage in the end. Yeah, I think that's the first part. There is a deeper dive into legacy type mapping within the advanced 2 training, but I think that's okay as a basic step into legacy type mapping for now. There are 2 topics left till 9, so I want to go further. If there are no questions so far, okay, another question, so go on.
Yeah, sorry, just another quick question. It's quite confusing to me. You said if you have quite a big, a lot of changes that you have to your data structure and your models, no? And you say you do it step by step into production.
Yeah.
But if this changes also changes the logic inside other parts of the code.
Yeah.
How would you suggest a strategy to do this? Because maybe step by step it's not feasible, or maybe.
Yeah, you are totally right. Not always this is possible. So if it's not possible doing that, I would recommend try it out. So you could do let's say a test run to see what happened when you do all the changes at once, and you will see in the console what happened at the end. So what value is mapped to another. So, and if you're fine with that, you could do this all at once, and then it's okay with your business logic also. But if this is not possible, use the explicit mapping. That will help you to do a lot of more steps in one together, and then this will help you with your business logic. But in the end, the question is always, what are differences to Hibernate at the end? And I think at the Hibernate level, it's always the same. Database changes handling is always difficult, especially with when business logic comes into play. You also have to change business logic on the Hibernate side when you change data types and so on. I think it's never easy doing that. It's a different way on EclipseStore side, but on the other hand, it works mostly the same like in Hibernate. You have to find a good strategy for you doing those changes.
Thank you.
Yeah, of course, that's a good point. There might be a way to write a test for the type mapping to see if it works out the way you expect. Yeah, that's totally okay. Yeah. I think on the con side, it feels a little bit different using EclipseStore because it's a totally new invented type of storage or database, I would say. And you always have to think about more out of the box because it's new, it's working different, and it's a totally new approach. On the other side, it's quite fast and easy to use within Java, of course. But a big advantage is that everything is Java. There is nothing, no other system in the game, and you could do whatever you want, what Java brings to you. And there are so much more opportunities handling your data, using third-party frameworks, whatever else. It's totally up to you. Using a JIT, for example, with the refactoring and so on, many possibilities. But is there a chance to change the type like from string to integer? This is exactly what I'm talked. It's not possible in an automatic way. I mean, it is possible changing that. But you have to transfer the data in a way, and for that you need business logic. And this is mostly we do it like this. So let's say, I don't know why, but let's make an integer out of that name and call it name2, for example. So this is the way we do it for now. So we create a second field, and on database startup, you can transfer all the strings into the integers. This could also be done within the get and set methods, right? So you could also use the get and setters for this, but then you have to keep the code all the time within your project. So I think that's I think that's not the best approach. So and I would recommend doing that transfer the data once and migrate it. And on the next startup, on the next thing, you could remove this at the end, and then you have transfer it. Of course, there is one thing you have to consider, the name change here. You have to find another name for the field. Yeah, but that's how it basically works. So you always need business logic somewhere to transfer the data. And that's also a good question. What is the more describing EclipseStore enterprise environment? Attempts to speed up or modernize old projects, or is it more applicable to ambitious new projects? I would say both. When I have a look to our projects that we do, so we have, in fact, we have both. I think it's not made for, let's say, we have a big Oracle database in our company, and now we want to transfer everything to EclipseStore. This will never work. So because of the whole ecosystem, and there are many client applications, they're accessing the Oracle database. But we currently are working with exact this situation, especially on the Fraport Airport, for example. They are having huge Oracle databases. And now they're starting to transfer everything to a more modular way. Let's call it, I have to be careful when I talk about microservices. I don't like that microservices part that much, but microservices are really great, but you have to handle it the right way. So, and a good opportunity is changing smaller parts. So breaking up big monolithic applications, breaking up that, and just creating smaller storage units with a specific good data which fits best together. Like I said, kind of like a module, to create a module out of a specific functionality. That works really great. And that's the approach where we modernize an existing one. On the other hand, when you create a new one from scratch, that is a great opportunity. So you could do whatever you want, and I think it's different, but it works for both approaches, I would say. But you have to be careful that this is an in-memory storage technology, and saying, okay, let's transform 400 terabytes of data to EclipseStore, that is not really a good idea. So you have to consider your data, you classify your data, you have to know what to do, so I would say. Okay, let's move on. Still 2 topics. Let me just double check my list, so not to forget something. So backups is a great topic. So let's start with the backups. I think that's really important, and I like that really much because it's a great technology. So there is, of course, there is a project I brought to you. So where is it? Backups. Backup strategies. Here we are. Okay, let me share this. Here we are. So this is the link for the project Backup Strategies. There is only one or multiple branches there. Okay, great. Okay, that's great. So okay, let's start at the branch continuous backup done. I think that's the first step of backupping stuff with EclipseStore. As I already mentioned, there are 2 strategies of backupping things. The one is, we call it continuous backup, and I would call it kind of like a mirror. That means whenever we store something to the main storage, a mirror will be written at the end to a different storage. So this is the first strategy we use here, and it's quite easy to use. So let's open the DB class and let's have a look to this. Oh, unfortunately, yeah, okay, that's okay. So let's jump into the MicroStream XML file. So you see within that project, it's configured with an XML file, but it's the same working with the builder pattern and so on. You just add the line .set backup directory, and it works the same way like here, backup directory. And in this case, I set the backup directory right into the normal folder of the main storage. That doesn't make really sense because, but that is not important for now. More important is that whenever we write down data to the main storage, an automatic mirror will be written to the backup folder. And this is how it works, and that's all you need. So that means automatically you write kind of like a replication to another folder. So let's give you the evidence for this. So source target application run as Java application. There's a, sorry. I just have to do a Maven update first. Now it looks like it should be. Okay, so I have to double check the controller. yeah, create. Let's call the books create method. It's always the same. Books/create. Okay, books are created. Now let's have a look to the storage. You see the data folder here, and now you see exactly what I told you. So we see the 4 channels here, and we see the persistent type dictionary, and we have the same on that second folder. And this is a great opportunity using this mechanic for creating a first level backup system on maybe 2 different persistent volumes. That means we have one volume, which is for the primary storage, and we have a second volume for the backup itself. So in case of emergency or in case of a database crash, for example, just copy the storage from the second volume to the first one. That's as easy as it could be. So it's just copying the binary files. And this is exactly how it works. And there is nothing more to explain about that. And that's the first layer of backupping stuff. Any questions so far? That's easy, I would say.
Oh, Christian, if that is not the best way to do it, then what is the recommended way to do it?
Yeah, okay. That brings me to the next step, to the full backup functionality. And you might say, okay, why do we need a full backup functionality within EclipseStore? We could use some mechanisms from Kubernetes, for example, by cloning a persistent volume, for example. This will work, but it's not by far not the best way, because you never know if EclipseStore is writing data right at that moment you create a clone of that persistent volume. And that's the reason why you should always use the internal mechanism of creating a full backup or stuff like that, because it's part of the main thread of the storage itself, and you will never get data lost or destroy your storage. This is really important, because I've talked with customers. They used EclipseStore and MicroStream for years, and they have never ever any issues. And then for years, and then they moved to Kubernetes, and they used that that clone functionality to create backups, and they destroyed the storage. It could to creating a backup like this could work 15 times, but on the 51 you will crash your storage, because you clone the storage at the exact moment EclipseStore doing some writing stuff on it, and then it's half and it's broken at the end. So therefore, I always recommend doing or using that full backup strategy at the end. So let's move on to the next branch. Switch to full backup. Done. Okay, yeah, I have to. Team, switch to full backup, done. And therefore, we mostly using the framework Quartz. Maybe you already knew this. It's a framework for doing background jobs within a specific time range. For example, doing stuff always at 12 at night, for example, or at in the morning at 8, whatever. So and it's especially made for this. And in that implementation, there is one task. This is the task itself. It runs in my example. It runs every minute, right? So this is the cron schedule. It runs every minute, I guess. Yeah, I'm not an expert in that. I always have to read the manual, but that is not that important. Let's have a look to the task itself. And this is the line which handles the full backup. That means every time when backup is running, it creates an issue full backup on that specific file system. And that's and the file system could be an AWS S3 bucket, for example. And that makes totally more sense creating a backup on a totally different system, and maybe on a different region, for example, just to have it in case of disaster recovery or stuff like that, having a backup somewhere else to copy it from. But this is, I would say, the best practice. So we doing that exactly this way. So that means we have, most of the time, sometimes we have that this way, that we create a mirror on two different persistent volumes. That means one volume for main, second one for the mirror, and full backup on an AWS S3 bucket, for example. This is how we do it sometimes. And sometimes it's also possible doing this persistent volume for main storage and the mirror on AWS S3. And I brought you also an example or a configuration of this in the next branch. Just a second. Should we start this? Is that interesting for you? So we have to wait 2 minutes until the full backup is created. Let's do so. We have that time. So I just have to check if we just have to delete the storage just to ensure that we are. Close. Oh. Maybe there is a version change in the POM XML, but yeah. Okay, now you see the cron job is up and running, the scheduler, and now we have to wait. Let's call a create first, so that data is created now. Okay, so let's check. You see that books data is here, so there is an ISBN and the name, origin, and so on. So data is in it. Yeah, that could be exactly, that's the answer to Nathan. So in your project, do you include a continuous and a full backup? Yeah, exactly. So now you see backup successfully done. So now we should see the folder somewhere, hopefully. Yeah, you see that? So that means we have the data here, we have the backup here, and this is the full backup, and it's here. So that is really easy to do. It's just this little one line of code to create a full backup within the task I already shown to you. That's it to creating a full backup. Of course, you have to take care about to say, sometimes we create those incremental backups. So that means we create a full backup on Monday, on Tuesday, Wednesday, and so on, till 7, a set of 7 backups. And after that, the 8 ones will overwrite the first one, which is made on Monday. But this is on you to create this on. So what happened here? I don't know, for backup topic. Data is not empty. This is why it's already there, and he's not allowed to update it. So that's why the error is here. But I think you get the idea. And this has to be implemented by yourself, the handling of your backups. But this is part of your specification. It's up to you. I think it's enough to know, okay, how to create a full backup and how to create a mirror backup. And on top of that, I want to share with you a strategy in the next branch. It's switch to backup on an S3 bucket. That's an interesting one, just because of the configuration. And now you see that horrible, I would call it horrible, boxed initialization of the storage. Unfortunately, when you want to create a mirror on an S3 bucket, you have to do it this way. And let's see, we create the file system here. Oh, this is the backup S3 file system. And now you see set backup setup. And storage backup setup, new, and then you have to add the file system. That means the Miro will be written to an S3 bucket. In that case, just for you to know you have the project, you could check it out and see how it works basically. And this is one approach, writing the main storage on persistent volume or hard disk, and the Miro is written to AWS S3, for example. It's a possibility. So it gives you an idea how to handle backups and so on. And I think it's totally enough for any situation you want to insert within your project. Any questions so far? That's it about backups. It's not a difficult topic, I would say. So during the question, I will move to the last topic for today. And this is the topic I missed at the beginning because of time was running out before the break. So it was where is it? Configuration, was it? Just check. Okay, this should be the exception handling. Here is it. Okay, so let me share the project with you. So it's all about exception handling. And in my opinion, that's also at the end of the training, it's also an important topic because on the con side of EclipseStore, there are some things you have to consider. And exception handling is one of that. So let me explain this a little bit more in detail. There is, let me just check if there is a presentation for that topic. Here you are. Yeah, okay. So it makes sense to start here. Advanced storing, and storing data or storing data in an advanced way has some relations to exception handling. Let's get into it. So the basic store function we always talk about look like this. So we create a book with some specific values, and then we get the collection of books and add the book, and at the end we call the store method on the books itself, on the collection itself, because we changed the collection, so we have to store the collection, or we have to store always the reference folder. So I would call it like this. So this is really this is okay. We already knew this. And then there are some advanced store functions. We differential, is it the right word? Yeah. Some different store strategies. The one is the lazy storing, and the other one is the eager storing. So just to explain you the lazy store at first, lazy storing is the default behavior of storing data. That means, let's say we have a customer, and that customer has orders in it. And when we changing something within the customer, maybe last name, first name, whatever, and we do also some changes on the orders of the customer, that means when we use the lazy storing behavior, only the customer itself will be stored. This is because, and the reason for that is that we have that appending storage, right? So that means whenever we call the store method and we would always store all the nested objects below a specific one, then we have to attach all the graph below a one specific element, attach it again and again. And therefore, the lazy strategy is just storing that object which is passed to the store method, right? So when we pass or when we hand over the customer object, only the customer will be stored. That is the lazy storing behavior. And this is exactly what is written here. There is one exception, and this is what happened if we created a new customer, and that new customer contains an order which is also not stored before. So, and when we add that customer, then the lazy storing will also store that order together with that customer. So that is the reason why it's always a little bit on reference instances are stored only if they have not been stored yet. If a reference instance has been stored previously, it's not stored again. And I think that's exactly the point. So when you add a new customer and it brings its order with it, then also these orders will also be stored within the lazy storing. And we have the opposite on the eager storing side. So then this is a special way to storing things. The eager storer is a storing, it stores everything, the whole graph below the handover object. That means when you hand over a customer on the eager strategy, all the orders will be stored, even if there are no changes within the orders. And if there is in the orders an address and so on and so on and so on, everything will be stored at once. Eager storing. It's not a default strategy, but that is the difference between both systems. The way to create an eager storer, you could do it like this, but I will come to that directly within the project when we talk about transaction and rollbacks. And we do this directly in the project itself. Let me just check if you are on the right branch. Master roll. Yeah, let's choose this branch and just jump into the controller. There is one example I created for you. Let me just find the right create book, get book, clear book, rollback. We do not need this. Okay. Okay, here we are. Okay, so you see that there is one method which is called update multibooks. And all that stuff within the try catch is not that important for now. More important is the way that we store this. So that means we iterate over the collection of books with a for each. And then we say, okay, b.setPrice, and we set a new big decimal price on that book. Okay, so nothing special so far. So now how could we store this? One opportunity is to say, okay, after each iteration, we call db dot, db dot get storage manager dot store b. Okay, this will work. But why could this lead to a problem? Have you an idea? So let's say we have 1 million books inside that collection. Obvious, this will lead to a bottleneck, I would say, because the store method is a blocking method, and this will lead to, that blocks the for each loop. And this doesn't make really sense, storing that again and again for each iteration. That makes no sense, but it will work. So, and therefore there is the possibility to create storers. So, and I did this here above. There are two different ways creating a storer. Let's do it like this. So that means this is a lazy storer and this is an eager storer, and we could create an eager storer here. The differences between lazy and eager I already explained, and we could use an eager storer in the same way that I used the lazy storer. In that case, I created a lazy storer, and then I said, LazyStore.store B. And yeah, in some of you might say store is a little bit misleading. It's more a registration than a store. So that means the B, the changed book, is registered into that store for later storing. So that's what I mean. Store is sometimes a little bit could be misunderstood. So and at the end, the real storing happens on ls.commit. And this gives us kind of like a transactional behavior. So that means we are able to doing transactional stuff within Eclipse Store. That means using that store this way. And after all the books are registered with the changes, we could call ls commit. But, and that brings me to, so any questions so far from your side? That's important. Is that quite clear? So you could read all that stuff within the documentation. This is everything is described in the documentation, and I think that's okay to
Okay. I'm pretty confused about this, but maybe I should let you finish and then ask. I don't know.
Okay, so the point is that we do not want to store the data all the time directly to the hard disk, because let's say we have 1 million iterations here, and store is a blocking operation that will slow down the iteration. And
I understand that.
Okay.
I'm confused about how you get there. I thought that just calling store on the storage manager was a lazy store.
I think it's not important if that is a lazy store or eager store. The behavior would be the same in both cases. So it doesn't matter.
Great.
It's working the same way, but just to explain you, there is a lazy store and an eager one, and I think the differences are quite clear. But now we change a little bit to the transactional behavior, but it doesn't matter. The eager store behaves the same way like the lazy store, and therefore that's okay. I hope that, yeah, I know what you mean. That confuses a little bit because I jumped from lazy to eager to transactional behavior. So, but the point is, you will not be able to create you use an eager store in a different way. So you always have to use this line of code, for example, to create an eager store. It works the same way. That's why I jumped directly to transactional behavior, I would say. But okay. So why do we need that? So what are the big issues here? The problem is, what happens if someone goes wrong, maybe in line 45 or in 44? So let's say we changed 300 books, for example, and after the 301 book, there is something wrong. So what is the big issue in that case? And this is, I think that's the most important issue here. The problem is, I already told you that all your users are working on the same object graph. So that means the changes you made here are at the same time within the RAM when you're doing that. So you know what I mean? So when you call set price, every other user will see that changes immediately. So, but what if there is something wrong here? So then we have, at the end, we have 300 changes in the RAM, and the other 300 maybe are missing because of the error, and all the users see, okay, everything is working fine because the RAM is changed. The changes are here. You see the changes, but you did not know that something goes wrong in the background and the changes are not stored at the end. You see the problem? So what happened in the end is when you restart the server, you see that out of the data is changed when you restart the server, because when you stop the application, you will see that all the changes are not stored at the end, and you will get old data at the end. And that leads me to that is important to using that transactional thing for and using try catch for error handling to cover exactly these situations. And that's why I want to get a little bit deeper into that. So that means this, I think this is really straightforward. So we create a storer, we register our changed objects within the storer, and then we, after that, when everything was working great, we call the commit. And that is in line 48, this is the moment where the data goes to the persistent hard disk, for example. And if something goes wrong, and now this is where the try catch comes into play. So we have to create a restore. So we have to restore the data. That means we need a reloader. And this is also one functionality. It's kind of like a rollback. And that rollback takes care about reverting the data which has changed before to the normal, status, I would say. Yeah, let's call it status. That means books for each reloader, reload flat. There are two different methods, reload flat and reload deep. And that enables a rollback of your data. Let's try to understand this a little bit more in detail. So the reloader needs, this is just the instantiation of the reloader itself. It needs an instance of the current persistence manager. This is what we get from the storage manager. You will get the persistence manager. And based on that reloader, we are able to call reload flat, and you have to hand over B. So this is exactly, B is the collection which should be changed. That means if 300 books are already changed and 300 not, this reloader will reload the book object itself to the state before the change. That means we changed the price to 50. If the price was 30 at the beginning, it will change back to 30. So that's exactly how it works. And the reason why there is a reload flat and a reload deep, so let me just show you, there is another method which is called reload deep. I mean, the name says how it works. Reload deep means it reloads all the sub-elements on all the nested objects. Also, that's what reload deep does. So we could try it. So so there are 4 minutes left. So if it's okay for you, so we could give it a try. Hopefully I could find, oh, come on. So I did a lot of changes here. Okay. So how it's switch to best practice done. Okay, let's leave it as it is. I think you get the idea how it works. I think it's all well documented, and if you need more information about it, just go to the documentation and see that. I think it's important to give you the idea that this is a really important topic, because I want to lead to another more important best practice topic in case of exception handling. And this is also something which is important to know. Within the next branch, I covered this situation on a different place, exactly here. So this is our DB class. You already knew this, and I created some wrapper methods around the EclipseStore methods to store things. The reason for that is, and I think it's the same problem or the same issue that we talked about. If something goes wrong on your storage, and the point is that EclipseStore is that close to your hard disk or to your persistent volume because it's one system maybe you use EclipseStore on a server where you have your own hard disk on your server. Then the system are so close together that what could go wrong at the end? So there is no connection which could be disconnected or something like that. So EclipseStore is working really, really stable. But in the end, I don't know, maybe the persistent volume is disconnected or something like this. And you will get an error message in your logs when you try to call the store method. That's okay. You will see that in your logs. But the user on the front end is not able to see that because he sees its RAM and he sees the changes are working like expected because the RAM has changed. But at the end, you will not see that the store isn't working anymore. And that's why I created a wrapper around the store to create something like on storage failure to shut down the storage immediately after something goes wrong. And I think that's the best way doing that, because if something goes wrong on the storage side, it's the worst case, I would say. And then you should stop the storage and investigate some research to see what's going on there. I think that's important, just to give you this as a best practice. I'm pretty sure you will be able to implement this in a much better way. But this is only to give you an idea. You have to care about exception handling, and especially if something goes wrong on storing data. To be to be honest, most of the time this will working really great. So it's quite stable, nothing goes wrong, and so. But only in case of, you should be aware of that. Stop the storage. Stop EclipseStore is the best way doing that on a failure on storing on the storage itself. Okay, yeah, it's a problem. Time is running out a little bit. I will cover those topics a little bit more and further on the Eclipse, on the Advanced 2 training, with some concurrency stuff and so on. But for today, I think it's enough. Information regarding EclipseStore. Yeah, any questions from your side? I'm a bit confused with change on heap propagation. It is following the JMM rules and not to be thought in ACID terms. Phew. Not sure if I get it right. So maybe Nikolai, maybe it helps if you write me an email. That will help me to understand what you're meaning with that. I think it's more on EclipseStore is working totally different than any other storage technologies on the market. You should not compare it to a relational database. It's a totally different approach, and it has its benefits, and it's fast as hell, and it's easy to use. But on the other hand, you have to deal with some special situation. You are not used to deal with it. So, for example, when you use a relational database, you mostly use Hibernate and so on, and you will get a user session within Hibernate, and you will get the data, especially for this one user. It's an isolated environment for each data, except the cache, of course, but it's isolated. So a lot of Java developers are not aware of handling concurrency, for example, the right way. So because of they don't have to in the past. With EclipseStore, this is a little bit different, because I would say the storage is the fastest that you can get on the market. I'm pretty sure about that. But on the con side, we have to deal with concurrency. Now, a lot of developers would say, okay, you have to deal with concurrency. That's basic stuff for every Java developer. No, it's not. I knew a lot of developers, they don't have any ideas of handling concurrency at all, even myself. So I think that's the con side. it's totally different. It's a different type of storage. Yeah, and it gives you a huge amount of performance, and the storage is that scalable. It's really incredible. I could give you some details on examples that we running thousands of users concurrent on the same system on really low budget machines, because the storage is that fast, that and the CPU usage is that low. It's really incredible. But on the con side, you have to deal with concurrency and with all the other stuff on Java, and that's different. In some parts, you are right. So maybe stopping the storage on failure could be a part of the framework itself. It's I think that's a good idea. In such suggestions would be great, having that within GitHub discussions for our developers. It's there is always room to improve things, also on EclipseStore. Make your suggestions, would be great to have that. And I think that's a good point for advising you to using GitHub discussion. It's open source. We have some people ask us to contribute things for encryption, for example. We are working on that. There are a lot more things to know regarding EclipseStore. And as I said, it's open source. Feel free to contribute. Feel free to be a part on GitHub discussions. And yeah, I think that's the point. Another question. To get the certificate, it's important to sign up with the same email address you took part to the training today. You sign up on our cloud environment. So, and if this is not possible, or you have a different email address, sign up here to the training to your already maybe existing account, just let me know. Send me a short email. Let me know that the email address is different to the one you are already signed up. Just let me know. I could do this for you. Sure. So the URL to the cloud platform is cloud. So just a second. Cloud microstream.one dashboard. So just use this one. Sign up here, and I would say 4 to 5 days after the training, you will see your certificate in the certifications section here. So I already showed this at the beginning of the training, and then you will see your certificate here. Okay. To run the same instance multiple times, for example, if one uses the app with EclipseStore and Lambda, and now 2 Lambda instances are running. Yes, of course, it is. Let me think about. I think the problem on your solution is, or on your thoughts is, that each instance has its own storage. You know, so you could run 15 lambdas, but each lambda is a stateful lambda. That means each lambda has its own storage, and it's always different. Because you will not be able to access one central storage from multiple virtual machines. That is not possible. It is possible in a read-only manner. That's possible. I mentioned that at the beginning, but I would not recommend this for production purposes. Maybe some corner cases should work like this. But you should use a real replication feature if you need this. That's why we provide our replication cluster within our SaaS solution. And this is also one part of the Advanced 2 training. I will show you all the cluster stuff we invented around EclipseStore. There is a replication SaaS solution, and there is also a replication on-premise solution for company internal having data replication with EclipseStore at the end. This could be quite interesting for you. So, okay, so thank you very much. Same on my side. Thank you for having you on that training. Hopefully that was interesting to you. Hopefully there was some topics that you need to know to go further with EclipseStore. I hope it was not that boring. If you have any suggestions, improvements to the training or stuff like that, just let me know. I shared my email address before. Let me do this again. c.kuemmel@microstream.one. Here it is. So if there are any recommendation, improvements, or some comments from your side, let me know. Thank you for having you. Have a nice day. Have a nice week.